Am I audible to everyone?
Yes, sir.
Thank you so much. It takes some time.
यूट्यूब में हम टाइम
तो ये वाला हमको बंद करना पड़ेगा।
यूट्यूब वहां से बंद टाइम लगेगा यार।
ये वाला बंद
Canteen में दो तो विनीत सर था कैंटीन में हरियाणी कैंटीन में पकड़ता
Hello. Good morning to all. Am I audible?
Yeah, you're audible.
Yes, madam.
Yes, ma'am.
Thank you. So, good morning, esteemed participants, experts, and colleagues. On behalf of Sumandeep Nursing College, Sumandeep Vidyapeeth, an institution deemed to be university, I am honored to welcome you to this national level e-workshop on addressing sample size estimation in complex study designs and strategies for critically appraising RCTs. It is a pleasure to have professionals, researchers, and academics from across the country come together to engage in such an important discussion. This workshop covers two important areas in clinical research. First, it teaches participants how to figure out the right number of participants needed for their studies, especially when the studies are complicated. Knowing the correct sample size will help us make sure the study results are reliable. Second, the workshop teaches how to judge the quality of medical studies called randomized controlled trials, that is RCTs. Participants will learn how to tell if an RCT is well done and trustworthy so they can use the best available evidence to make healthcare decisions. This workshop also explores fundamental aspects of clinical research, including the normal distribution of samples and meta analysis techniques. I encourage you to actively engage throughout the session. Let's make most of this opportunity to enhance our collective knowledge and continue to push the boundaries of research excellence. It's my honor to welcome our esteemed principal ma'am, Dr. Anita Prakasham ma'am, principal and HOD, obstetric and gynecological nursing, to deliver the keynote address. Ma'am's visionary leadership and dedication to academic excellence continues to inspire us all. Over to you, ma'am. Thank you, ma'am.
Thank you, Ms. Priya, for this wonderful opening. Okay, respected organizers, distinguished speakers, esteemed colleagues, and participants. Very good morning to all. A warm welcome to all of you. It's an honor to be here today at this prestigious National E-Level workshop. We will dwell into essential aspects of research. Today, we are going to discuss about sample size estimation and among this complex study designs and RCTs. As a researcher, practitioner, and statistician, we are all driven by reliable and impactful evidence, whether we are exploring new therapies or assessing the educational interventions and investigating the social policies. The foundation of credible research, it lies on study design. Among the many components of solid design and sample size estimation plays a pivotal role. A well-structured study is a backbone of reliable research. It determines not only the accuracy of our conclusion, but also the impact of the research study. Whether we are working in medicine or public health policy or psychology or in social science, a study that is methodologically flawed, any flaw which has happened can lead to mislead the result and as well waste the resources also. So evidence-based decision-making shapes the policy and treatments and innovations. So the responsibility of the researchers are never been greater. The credibility of our findings depends not just on the questions what we ask, It's completely bound with the design, and as well studies interpret how we interpret our data. Okay, why is sample size estimation is important here, especially today, why we are going to discuss this. Sample size estimation is not just a statistically formality. It's a crucial step that ensures our study is powered sufficiently to detect the effects we are interested in without overburdening the participants or wasting the resources. If our study is underpowered, we risk failing to detect the real effects. We cannot find what we intend to measure here, rendering our research inconclusive. Or, in other hand, if we overpower, we risk exposing the participants in unnecessary risk. So both are a problem to our research study. In complex study design, we need accurate sample size estimation becomes even more critical. These designs include, especially when you do multi-center trials, longitudinal studies, nested case control studies, involve many layers of variability and often require sophisticated approaches to determine the appropriate sample size. So similarly in RCT, so the gold standard of clinical and social research and sample size estimation forms the bedrock of valid conclusion. So few are the areas to be considered when we do RCTs. One is heterogeneity in treatment effects across the different population, and cluster the randomization, whether the entire groups are randomized or instead of individuals or special groups in calculation. And as well, the most important thing is we have to concentrate on dropout rates also, which need to be accounted for maintain the study integrity. See, usually, so we won't maintain that particular data whenever the patients are drop out. That also has to be maintained, and we must know the reason for dropping out from this research study. And stratification and blocking, which can provide more precision, but complicate the calculations. So what are the challenges and advanced techniques are there in the sense? Hopefully we know that. So while basic sample size calculation follow well-established formulas, the reliability is far more complex, and as well, especially when we deal with the data and real world settings. So moreover, so in current era, we have a lot of statistical software tools like SAS, SData, and R. We are empowered with the researchers to perform these complex calculations, which ease our study, and we can able to get analysis very easily. However, the critical knowledge to understand the assumption behind the numbers in something that we are practitioner must keep in mind. So call for a collaboration that, yes, of course, as we explore the sample size estimation today, I urge all the participants and as well the approach what we are going to discuss here. The challenges in this field require diverse in set of expertise. So here I'm meaning to say that so not only researcher, the diverse people also involved in this, like from the statisticians, subject experts, and data managers and trial coordinators. It's a mixture of all people involved in this sampling techniques and as well study design. Together, we can refine our understanding of the complexity involved and develop more precise estimation in methods, and as well we can improve the quality of research studies what we conduct. So in conclusion, I would like to highlight that a sample size estimation, while often regarded as a preliminary task, is far from our routine one. So it is a cornerstone of the scientific method. Yes, of course, ensuring that our research findings are valid and reproducible and meaningful. As we engage in the discussion today, let us commit not only mastering the techniques, but also to apply them thoroughly in our research. Once again, thank you for this opportunity to speak at this workshop. I look forward to the insights and knowledge we will share this coming hours. I'm confident that collective expertise in this room will lead to valuable outcomes for both our individual workshop and as well research in this community. Thank you, organizers. Thank you.
Thank you so much, ma'am, for delivering such an insightful and provoking keynote address. Now, I would like to highlight some credentials of our respected principal, ma'am. Dr. Anita Prakasham ma'am, MSc Nursing and PhD Nursing, presently working as a professor cum principal at Sumandeep Nursing College, Sumandeep Vidyapeeth deemed to be university. Ma'am has worked as a franchise lecturer at Liverpool John Moore University, UK. Ma'am has also taught in University of South Wales, UNISA, Australia. Ma'am has worked as a nurse lecturer at Malaysia. Ma'am has presented research paper in national and international conferences and workshops. Ma'am has also published research papers in various index journals. Ma'am has conferred with Best Research Paper in UK Health Research Congress. Ma'am has also guided many undergraduate and postgraduate and PhD scholars in their research projects. Ma'am is a lifetime member of Trained Nurses Association of India. Thank you so much, ma'am, for delivering such an thought-provoking keynote address. Your guidance and expertise have truly set the tone for today's session.
Thank you.
Now,
Best wishes.
Now, moving ahead, let's now delve into our session on estimation of sample size in complex study designs by Dr. Upu Praveen sir.
Next. Continue करो. Continue. Video. Video.
Dr. Upu Praveen sir, a lecturer at AIMS, Vijaypur, holds a PhD in nursing and has held
Share. Share कर. No, but from URS, it will be good.
Dr. Upu Praveen sir, a lecturer at AIMS, Vijaypur, holds a PhD in nursing and has held prominent academic roles, including associate professor and head of community health nursing at Sharda University. Sir has contributed to research on chemotherapy side effects and public health while supervising PhD scholars in projects. Sir has published extensively in Scopus and WOS index journals, served as a resource person for various workshops and conferences, and is proficient in statistical software and systematic reviews. Sir also plays an active role in university level programs and responsibilities. So now let's start our session on estimation of sample size in complex study designs. Over to you, sir. Thank you, sir.
Am I audible? Good morning.
Good morning,
Yes,
sir.
sir.
Yes, sir.
Yeah.
Mr.
Ma'am, thank you,
Praveen,
ma'am,
on
for
behalf
the
of
beautiful
Sumandeep
introduction
Nursing
and
College, I welcome you.
heartfelt thanks to the Sumandeep Vidyapeeth at the College of Nursing, especially Principal Ma'am and Suresh sir, for the given opportunity to be a part of this workshop. Is it my voice is okay? Is it low?
Yes, sir, it's audible.
Audible, right? Okay. So thank you once again to be a part of this wonderful. Hello, ma'am.
Good, how are
Okay,
you?
so yeah, fine, ma'am.
Yes, sir,
The
welcome.
topic which I got is some sample size estimation and I heard like a complex study design, right? According to me, there is no simple and complex when it comes to the research. It depends upon the researcher for you only. Maybe as per your concern, maybe the complexity in the sense might be RCTs. Am I right? According to your perception, the complexity study design in the sense maybe you are thinking as an RCTs. Is it
Yes.
so?
Yeah,
Okay,
yes.
so you are okay. But from my point of view, irrespective of the study design, there are certain things to be followed while estimating the sample size. Purely, yes, this is the work of the statistician. Basically, people say even if you do sample size calculation also, especially for the PhD aspect, the panel, when we come for the presentation and all, the first question they will ask, have you consulted statistician? That time, yes, we have to say, yes, we consulted. When you say, no, no, sir, no, ma'am, I only calculated, people won't entertain, because we believe that the statisticians will give the accurate sample size estimation. But nowadays, the trend is slowly changing nowadays. So even if you are well versed about the estimation, we can also do. But preferably, if you take the help of the statistician while calculating the sample size estimation, it will be better. Okay. So before estimating any sample or like sample size for any kind of design, there are certain principles or things we need to keep in mind. Um, so in this session, I am going to cover these aspects, like what is sample size, why we need to determine the sample size, and importance of sample size, and what determines sample size calculation. So in this aspect, we are going to cover uh, this almost half an hour or 45 minutes of session we'll cover. Okay. So the first question, how big sample size do you need? How big a sample size do you need? Audience? How big sample size do you need? I think somebody is texting or somebody can respond, because Suresh sir, I presented, I am in the slideshow mode. So if anybody are texting, please let me know from your side. Or if anyone want to share, they can say. How
Okay,
big a
I'll share.
sample size do you need?
Yes, sir.
Yeah. How big we need? Any answers? Any answers for the host? No. Okay. Uh, yeah. I think I didn't share the screen, right? Okay. Sorry.
Yes, sir.
Okay,
Screen
okay,
is not visible,
okay,
sir.
okay. Sorry. Um, yeah, now I will share. Is it visible now?
Yes,
Yes.
sir.
Yeah. Okay. Yeah. Anyway, I will show the overview of the today's session. Sorry, guys. Sorry. Yeah, the overview of this session, like I'm going to cover in this aspect, like what is sample size, why we need to determine sample size, and importance of sample size, and what determines sample size calculation. As now it comes to the question, how big a sample size do you need?
Minimum 300 samples.
Minimum 300 sample. Yes, very good, ma'am. Any other? Sir, we don't know, sir. That's why we are attending session, right? Right? This might be a proper answer. Okay, fine. It's a fundamental question. Yes, it's a fundamental question. Should be addressed. It should be addressed after determining the primary objective and study design. Is it clear? So it's a fundamental question. How big sample size, a sample size do you need? It's a fundamental question, and should be addressed after determining the primary objective and study design. So we cannot say randomly, because it depends upon the study design and your objective. So you have to determine the sample size based on your objective and the study design which you are following or adapting for your research study. Okay. What is sample size? What is sample size? Sample size is nothing but number of units or subjects. We can call as a participants, or we can call as a subjects also, to be included in the sample or the study. Who all should be involved for determining the sample size? Any guesses? Who all should be involved in sample size? Sample size estimation? Any responses? Who all should be involved? Any responses? I think participants are proactive. Yeah, who all should be involved in sample size calculation? Anyone, please. Anyone? Yes.
Number.
Oh my God. What are you looking at?
Any guesses? Who all should be involved in estimation of sample size?
Researchers, investigators, statisticians.
Okay, ma'am. Good, ma'am. Good, ma'am. Yes, yes. What happened to this? Yeah, clinicians or the physicians, statistician, investigators, sponsors. Okay, these are all people must be involved in determining the sample size. Why? That we will see. Let us see some questions. What proportion of 30 to 50 years of old people are hypertensive in Noida? Imagine. These are the some of the questions. And what is the average serum cholesterol level among hemodialysis patients? Then, does the proportion of the side effects differs between two treatments? On an average, the serum cholesterol levels differs between treatment A and treatment B. All these studies are based on sample size. So if you see, there are certain, like in one question I mentioned as a proportion, in some question I mentioned as an average, like that. So all these kind of questions, studies are based on the sample size. Objective of sample size estimation. Why we need to estimate the sample size? What is the objective of sample size estimation? Any responses? Objective of sample size estimation. Anyone? You must be a bit active, because next we are having some hands-on sessions, so you must be a bit active. Any response? Why? What is the objective of sample size estimation?
To control type 1 and type 2 error.
Okay, sir. Good. Any other? I think somebody still
To generalize the results, sir. We need to
generalize the
estimate.
research. Okay, sir. Good responses. Thank you. To estimate a parameter with a desired precision, we can call it as a margin of error and confidence level. What is margin of error? Amount by which the result from the sample is expected to differ from that of the target population. For example, when you want to estimate, simple example, knowledge of the school children about hand hygiene practices. Okay, like for example, you want to do this study in some rural setup of Gujarat, right? When you do this study, you are assuming that comparatively this school, when you do the study, other school children might be having some level of knowledge. The difference, for example, we can say as a 10% of difference, like the good level of for example, if you do the study in rural area, you might be assuming that around 50% of the students might having good level of knowledge on hand hygiene practices. When you do the same study in some other setting, private setting, you may assuming that they might be some 60% of the children, 60% of the school children having good level of hand hygiene practices. That 50 to 60% difference, how much? Almost 10% of difference. So that 10% of difference is nothing but the margin of error, amount by which result from the sample is expected to differ from the target population, because school children is your target population. So when you do the study in one small setting, when you generalize, when you want to generalize the thing, how much difference you are expecting, that is called margin of error. This is very, very important in estimation of the sample size, decided by the investigator. Who will decide this margin of error? Decided by the investigator, or they can go to the literature review, or they can get the expert opinion. Anything can be done to determine the margin of error. When it comes to the and one more thing, to estimate a parameter with desired power. Everybody are talking no power. Actually, what is power? Power for correct detection of a pre-specified clinically or statistically meaningful difference at a given level of significance. In a simple term, power is nothing but ability of a test to detect a real difference. I think power and these are the not very new words. Like we used to hear these words and all. But in a simple term, power is nothing but the ability of a test to detect a real difference. Okay. Sample size importance. Why sample size importance? Because somebody is getting admitted. Yes. There are certain scientific reasons, economic reasons, and ethical reasons. In the welcome address keynote, principal ma'am has highlighted few areas like that we can discuss, that we are going to discuss in a brief manner. Yes. What are the scientific reasons? What is the importance of sample size in the aspect of scientific reasons? For example, too small sample size result in underpowered study. Yes, ma'am already mentioned about these things. May fail to detect a clinically important effect. Like, for example, you did some study where you recruited some 50 participants. Instead of 100, you recruited 50 participants. So maybe you got some clinically significant result, but clinically it may not detect clinical aspects. So even there is a big debate between the clinical and statistical significance. There are certain studies where they prove that yes, the particular medicine is effective in reducing certain discomfort of the pain. But when it comes to the statistical point of view, it doesn't show any significant difference. Whom we have to believe? Whether we have to believe the clinical difference or statistical difference? What we will believe? Clinical or statistical? In such dilemma, to go with the clinical difference or statistical difference?
Clinical.
But statisticians say no, statistical.
But still, we need to consider this
Mm.
confidence interval
Mm.
that will be helping you us to take some decisions.
Yes, yes. Now you coming confidence interval is the part of the statistical aspect, right? So there's a
Yes.
big debate. So even one more thing, there is nothing wrong and right in research also. So many things are there, right? Even when we try to formulate an hypothesis also, different people forms the style of writing hypothesis is varies between people and people, but we cannot say it is wrong, or sometimes we cannot say it is absolutely right also. So in a research always there is a debate, debating issues about every point we can take, and we can have a debate in research aspect. So this we have to consider whether clinically we have to go or statistically we have to go, or clinicians say, no, statistically, like particular medicine is relieving discomfort. Yes, this is okay. But statistical point of view say, no, you cannot go something. There may be some hidden results. We need to go with the confidence interval like that. So it's always a debating issue. Then when it's come to the two large sample size, result is oversized study. May detect an effect. I said right now, I said no, may detect an effect as a statistically significant, which has no clinical importance. So, there is a problem with the too small sample size as well as too large sample size also. So, we need to balance those things. Too small as well as too large. So, we need to consider sample size for the scientific reasons. When it comes to the economic reasons, yeah, too small sample size. An undersized study may result in a waste of resource due to their incapability to yield useful results. A too large size, an oversized study may result in unnecessary waste of resources, cost and time more, etc. Yes. This is also one of the reasons we need to consider while obtaining the sample size. Ethical reasons, yes. Ethically, right now, when you submit for an ethical clearance, no, first they will ask, submit the proposal along with sample size. Why? Have you thought anytime why these people are asking sample size collection? Have you experienced anyone from the webinar? When you submit for the ethical clearance, usually they ask submit sample size. What might be the reasons why they are asking? Sir, it is in the application or the proposal format, so we have to do. Or is there any hidden reasons for ethical committee expect us to
To get
submit
the
the sample
reliable
size?
results, sir.
Hmm.
To get the reliable results. Otherwise,
Okay.
we may get some bias in the result if you are selecting if you're not following this proper sample size estimation.
Okay. Okay, sir. Good data. We will see. Might be the reason. Yeah. An underside study can expose subject to unnecessary, sometimes potentially harmful or futile or treatments without acquiring any additional knowledge. See, like when you are taking much efforts to do the study, when you are recruiting the participant which are undersized way, so your efforts are ultimately waste only. Okay. When it comes to the large sample size also, an oversight study, the same thing. It will harm, sometimes potentially to expose unnecessarily large number of subject to the potentially harmful or futile treatment. So like harmness, don't think that harmness is not always some kind of drugs or some kind of treatment only, because like even asking someone about their personal aspects also or disturbing someone in their routine also, it's kind of some kind of harm only, right? So don't think that harm in the sense always some kind of drugs only. When you are interacting with someone with some kind of questions also, it is like disturbing someone life cycle or routines only. So that's why the ethical people will consider the sample size. They will see that are they are recruiting too small sample size or they are going for the large sample size, especially even when it comes to the RCTs which involved in the some kind of interventions where there is some kind of disturbance in the routine or it may cause some harmness to the participant. So to avoid all those things, the ethical people expect the researcher or investigator to submit the sample size along with the proposal. So these are the three reasons. One is the scientific reason, and one is the economical reason, and one is ethical reason. Okay. There are two situations where we need to focus on the estimation of sample size. Any ideas? I think already one hint is there on the screen. Any idea? Two situations where we need to determine the sample size. Any guesses? Already one hint is there on the screen.
In both areas,
Sir, pardon, sir?
in both we have to determine, sir.
In which situation? There are two situations where we need to focus or obtain the sample size. Anyway, one is estimation, one is hypothesis testing. These are the two situations where we are supposed to estimate the sample size. Let us see. Situation 1, estimation. What are the various estimates we use in statistics? Any idea? Just estimation. Simple. Even I showed earlier slides also. Any example of estimation? Anyone?
Prevalence of some diseases, infection rate,
Prevalences, okay.
infection rate in the hospital.
Okay, prevalence, you want to say the prevalence. Okay, sir, good. See, mean, proportions, sensitivity, specificity, correlation coefficient, etc. Where we are not going to test any hypothesis, just we are going to predict what is an average, what is the proportion, how much percentage the people are having this. Sir, what is their correlation between two variables? Like that, in those scenarios, we are going to estimate the situation. Request to allow the multiple present to share. Hello, yes. Okay. The second one is situation 2. Yes, hypothesis testing. Like when it comes to the hypothesis, usually we compare the mean between two or more independent groups, paid data between two or more groups, or comparison of two proportions, or testing correlation coefficients, odd ratios, risk ratios, etc. In these situations, we are going to we are going to estimate the samples. One is for the estimation as well as hypothesis testing. Like estimation, simple, you can say simple surveys, simple prevalence studies, where we are not going to test any hypothesis. But for that also, we need to have a sample size calculation. When it comes to the like on our cities, like randomized control trials, where we need to determine the actual difference between the groups, that is called hypothesis. In that scenario also, we need to estimate the sample size. For example, I think these two are the very common and confusing errors, right? Type 1 and type 2 errors. Still, people, we were like, even though we take repeated classes also, but always there is a confusion of remembering these two. In a simple way, for example, this table, I think everybody knows about this table. Accept null hypothesis when it's true, correct action. Accepting null hypothesis, but like actual scenario, there is no relationship, but we will say there is a relationship. That is called what error? Type 2 error. Why means always as a researcher point of view, like students, especially MSc level students, know what they supposed. I had an experience. Like for example, when results are not coming significant, they are very worried. Sir, what happens? Sir, results are not coming statistically significant. Usually our hidden thing, like a hidden motto of every student point of view, they will expect the result should be a statistically significant, but there is no relationship. For example, there is no you want to find there is a significant difference between treatment A and treatment B. You want to prove and you want to say that yes, there is a significant difference, but unfortunately you got the statistical result saying that there is no significant difference between treatment A and treatment B. From the student point of view, we will say no, 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 there is no statistical significance. Whatever the research we have done, it is waste only. Actually speaking, no. During that time, we will try to commit for the type 2 error, saying that there is a relationship. And there is another scenario, reject the null hypothesis. Okay, reject the true null hypothesis means what it is? There is no relationship. Okay, but what we will say? We will try to say there is a relationship. So like that. So this is bit confusing, but always remember any one error so that you will not get any confusion. So when there is no relationship, you will say Yes, there is a relationship. When there is a relationship, you will say there is no relationship. Like that, it will go. Okay. So these two are the very important. There are certain terms for type 1 error and type 2 error in statistical term that I will show to you. See, for example, probability of type 1 error. How we can minimize the chances of type 1 error by fixing the level of significance, that is nothing but the alpha. Probability of type 2 error, how we will minimize? By fixing the power of the test. Any idea what are the common level of significance alpha where we use for the studies? Level of significance, what is common user value? You people know. Alpha.
95 percentage
Sir?
means level of significance is 95 percentage.
Yeah, that one only. Yeah. Coming to the power, any idea? What are the common used powers? Any ideas? Anyway, I will show you. Yeah, thank you, sir. Thank you for the kind response. Yes, these are the common use values. When it comes to the 90, if you want to say in the confidence level aspect, 95%, this is the fixed, these are the fixed values in the statistics, like a plus b whole square, like that. These are the commonly used values which are fixed in the statistical point of view. When it comes to the 5% level of significance, the value is 1.96. When it's to the come for the 1% of level of significance, 2.58. Higher the value, for example, higher the value, chances of the particular errors are less. See here, 80% power. This is the fixed value. That we the importance of these values we will do once hands-on, then you will understand. So 95%, 90% power means chances of type 2 error are only 10%. 1% power is 1% power means chances of type 1 error only 1% out of 100, because now we need to accept certain kind of by chance, any result yield by chance. There is, I can say, no, there is no perfect thing in the universe like that. We cannot say that yes, whatever we do is absolutely or 100% correct, because there may be, for example, treatment A worked better than treatment B. 99% you are confident that this is actually due to this is due to actual effect, but 1% might be by the chance. That is the actual meaning. When it comes to the 5% level of significance means whatever the results are yield, or we got 95% due to actual effect, and 5% may be due to some error. This is the actual meaning. When it comes to the power, 80% means what are the results we are getting? 80% are due to actual effect, and 20% by type, there is a chances of type 2 error. 90% means 10% there is a chances of type 2 error. So we need to give certain amount of chance for yielding the result. Then sample size computation for estimation of the mean, estimation of the proportion, estimation of sensitivity, specificity, independent sample t-test, one-way ANOVA, pay t-test, correlation coefficient, repeated measures ANOVA, comparison of two proportions. If you see now, all are differ based upon your objective as well as study design. Even yeah, some points to be carefully consider when you are obtaining the or estimating the sample size. The first most important thing is study objective or hypothesis of interest, study design, number of study groups, and clinically meaningful difference. So these are the very important points we need to consider before estimating any sample size. What are those? Study objective is at most important, as well as the hypothesis of the interest, study design, number of study groups, and clinically meaningful difference. So let us see example of estimation as well as hypothesis one. So estimation of the mean, if you want, you can make a note also. Yeah. See, what is the average cholesterol level among 55 plus aged people in Bareilly? I typed order, but I didn't save, I guess. Imagine the scenario. What is the average cholesterol level among 55 plus aged people in Vadodara? This is your question. You want to estimate the average cholesterol level among 55 plus aged people in Vadodara. This is nothing but the estimation of mean or average. Average, what is the another name of average, is nothing but the mean only. See, here I think typing error, sorry, Vadodara. A community health officer is trying to determine the mean cholesterol level of the age group 50 plus in Vadodara. She or he asks, how large a sample size do I need? Imagine any community health officer has come to you and they want to determine the average cholesterol level among 55 age plus population. So they come to you and they, to the statistician, or come to you and they want to ask how large sample size do I need. For that, we need to ask the researcher certain questions like, how accurately do you want to estimate? That is nothing but acceptable margin of error. What level of confidence do you intend to use? 95% confidence are typically used commonly. And possibly, what is your current estimate SD of the variable? Like, for example, here, what is the variable in this example? In this example, what is the variable we want to study?
Cholesterol level.
Yes, cholesterol level. So SD of the standard deviation of the particular variable we need to obtain. Then yeah, to determine the mean cholesterol level of the age 55 plus group in Vadodara, summary measure is nothing but the mean. Objective is to determine, and the summary measure is nothing but mean cholesterol level. Okay, what is the formula for this? Yeah, as I told now, we need to have, obtain certain values. See the precision level, that is margin of level. Here I fixed 5 milligrams per deciliter. That up to the researcher interest that they can decide, like researcher or investigator can decide. And confidence level, typically the 95% confidence interval. I said no, for this is the Z1 minus alpha by 2, the fixed value 1.96. And from the previous study, we got that the standard deviation of the particular variable is 20 milligrams per deciliter. So this can be anticipated or estimate the HD from the previous studies or expert advice or a pilot study. By obtaining this, we can get the standard deviation of this particular value. So coming to the formula, this is the formula. This is the formula of estimation of the mean, n equal to Z alpha minus 2 into HD divided by D. So from the example, if you see, D is 5 and Z minus alpha 1.96 and HD is 20. So with this, try to apply in this formula 1.96 into 20 HD divided by F. 5 margin of error whole square. Just calculate and tell somebody. What value you got? Somebody, please calculate and say. Anyone?
61.46, sir.
How much, sir?
61.46.
51.46. Anyway, let us see.
61.
Okay, 61 or 62. Okay, fine. So almost everybody got around 60 samples. So to obtain, to rule out the average cholesterol level of 55 plus population with the estimated margin of 5 and SD of 20. So we need to we need a sample size of 62 to get to estimate the average cholesterol level of 55 age people in the Vadodara. Why? Because if you want to collect from everyone, you can collect, but there are certain aspects, right? We need to look for the resources, wastage of money, everything, right? So to avoid all those things, to estimate the average cholesterol level in the 55 age group, how much sample do you need? At least you need 62 sample, so that whatever the result you get, you can compare with the population. So the thing which you are doing is, here is the statistic. When it comes to the population, it's called parameter. So the whatever the statistic you got, that you will compare with the population. So or else you can go now every 55 full Vadodara city, you can go with each 55 plus aged people and you can collect. Is it possible practically to cover all 55 plus aged people in Vadodara city? Is it possible?
No, sir.
Might be possible, but it takes a lot of time, right?
Yes.
Taking a lot of time and wasting a lot of resources is one of the ethical concerns. So instead of that, instead of going every 55 plus aged population, you just randomly select some 62 people and you can get the statistic. With that statistic, you can compare the population of the, for example, you might get some 25 cholesterol, mean cholesterol level. So you will predict that the average cholesterol level of the 55 aged population in and around some 25. Like that, you can predict the value. You can estimate the value. So the minimum number of subjects 55 age group required for the study is 62. One more example. Yes, this is the, when it comes to the RCT, this is very important sample size formula. Sample size for independent sample t-test. You can make a note. We can go for the hands-on also. Same as usual. This is the formula for independent sample t-test, where Z is significant level and Z1 must be is corresponding to the power, and SD, the common assumed standard deviation between the two groups, or the population standard deviation, and clinically significant difference. So these are all we will obtain from the previous studies or the expert opinion we can collect, like that. So can you please make a note down of this formula so that we can have one more calculation? Can I proceed?
Yes, sir.
Yes, sir.
Okay. Let us see with an example. Start recording. Okay. What is the something correct? What is the minimum number of sample required in each group to detect the difference in total cholesterol level of 20 milligrams per deciliter between the two groups with 5% level of significance, 90% power, and 35 milligrams deciliters of SD of the total cholesterol population? This is the question. So how much of sample size you require to detect the 20 milligrams deciliter between the two groups with the 90% power and 5% of significance, and SD 35 milligrams per deciliter. Try to apply these values in the formula and calculate and tell me. Yes, this is the fixed value. When it comes to the 95% of power means 1.28 is the value, and SD is 35 and significant difference is 20. Try to apply this one in the formula, these values, and let me know how much you got. How much? Anyone tried? Did anyone try? Can I show the formula once again?
Yes, sir.
Can I show the formula?
Yes, sir.
Yeah, this is the formula. Hope everybody written the formula. So now I'm showing the values. Yes. Anyone got answer? Especially for the RCT point of view, this is very important for me. When you are having an RCT where there are two independent groups, this is the ideal formula to estimate the sample size. Any answers? No. Yes, yes, ma'am. Somebody.
64.
Ma'am?
64.
64. Somebody chat also. Acha, 64.25. Okay, somebody else. Deepika. Okay, fine. Let us see. So number of subjects required in each group. Okay, number of subjects required in each group. It is 64.29 that you can make as a 65. Is it okay, or is there anything to be added for this? The 65 in each group is okay, or anything to be added in this? Something is missing.
Dropout rates.
Yes. Very good, ma'am. Very good, very good. It's nothing but the attrition, right? So up to 20% of attrition we can take. For example, if you calculated 65 in each group and you were very confident that, okay, I want to take only 65 in each group. Maybe in the long run, maybe after some times, there are certain chances that the participant may drop out from your study, because we cannot force any participants to be like, when you give the consent, there is a one point saying that you have rights to withdraw from the trial any point of time. So there are certain possibilities that the participant may be dropped out, or maybe depends upon the study also, maybe death also may occur. We don't know anything. So to avoid all those things, we need to fix the attrition up to 20% we can take, not more than that. You can take 10 also, you can take 5 also, you can take even 20 also. For example, if you take 10% extra, how much more we can for 65, 10% extra of 65, how much? 6.5 means 7. Okay, almost 7. So almost 72 in each group you can take. 72, if it is 10% attrition, 72 in each group, not total. 72 in each group. So, and one more thing, we have to be very careful. Whatever the dropouts no should not lesser than the actual 65. So we must be very careful when recruiting. So this is actually obtained formula. So whatever the participants you are taking with the 10% of attrition, maybe around 72 in each group, the dropout should not be less than 65. This is very, very important point. You may like when there are more dropouts, then try to recruit 20%, or like 20% means one more 7 participants you can recruit, like that. So always suggest go with the higher attrition percentage. It depend, you will understand when you enter in actual RCT, you will understand what are the possibilities of dropouts. Depends upon that scenario, you can fix the attrition. But the important point is, whatever the sample size at the end of the trial, the sample size, the participant number should not be less than the actual sample size. This is very, very important. So when you do the less than that, then nobody accept. Yes, your obtained sample size is this much. then why so many dropouts. So results may not accepted very easily for this scenario. So this is very, very important point. The after like during the study period or at the end of your study, the actual number of the participants should be, like for this example, should be 65. It not be less than 65. If it is less than 65, then maybe it depends upon the panel, they may suggest in a different way. I said no, there is no right or wrong in the research. This is very important. Any questions from the participant side? I can take. Because sample size estimation, few universities even they may conduct even 2 3 days of workshop also, because one study design and one objective have different types of formula to calculate. But anyway, I hope I enlighten you with the few aspects or few points to be considered while obtaining the sample size. I hope. Any questions you may pose?
Excuse me, sir.
Yeah,
Is
yeah,
it
ma'am.
compulsory to keep the attrition rate 20%?
That's what I told now, ma'am. It depends upon the situation. Up to 20% you can take. Up to
Okay.
20% you can take. You may go up to 5 also, 10 also, but it should not exceed more than 20%.
Okay, sir. Thank you.
Okay, ma'am. Any other? I think now it's time for the break, I guess. Then after half an hour, we have one more session. Yes, sir.
Thank you,
Suresh,
sir.
sir, can I stop?
Yes.
If there are more questions, then we can stop. Any questions anyone want to ask?
Thank you so much, sir, for delivering such an insightful session on sample size estimation. Your expertise and detailed explanations have greatly enhanced our understanding of this crucial aspect of research design. We truly appreciate your time and effort in making this session informative and valuable. Now, it's time for a short break. We'll be back after 15 to 20 minutes. So, we'll be back after break. Thank you.
Okay, thank you.
Wait.
Yes, please. Okay, so we'll break the session for 20 minutes. Thank you.
મને
Hello, good morning all. Am I audible to all?
Yes, ma'am.
Okay. So, after a short break, now we'll start with our next session. Sir, can we go ahead with our next session?
Yes, ma'am. Yes, ma'am.
Okay, we are now ready to begin our demo session. In this session, we will explore different software tools that assist in accurately calculating sample size for complex study designs by Dr. Upu Praveen sir. Our expert will guide you through the functionalities, features, and practical applications of these tools to help you make informed decisions in your research. Let's get started and enhance our understanding of how to effectively use these software tools for reliable sample size estimation. Over to you, sir. Thank you, sir.
Yeah, thank you, ma'am. Yeah, is my screen is visible? Desktop screen, laptop desktop.
Yes, sir.
Okay, fine. Just confirm whether all tabs are visible or not. Right? This is also visible, right?
Yes, sir.
Okay,
Yes,
fine.
sir, visible it.
Okay, fine. Thank you. Before starting this, any idea what are the various softwares which are available from your point of view? Because there are lots of softwares. Any idea or anything which you come across? Any softwares? Anyone? What is waiting? Let me tell. Anyone heard about anything or which you used earlier, or at least you heard the name? Nobody.
No, sir.
Yes, somebody is saying something. No one? Somebody chatted. No. Somebody chat. Yes. SPSS. SPSS. But SPSS, do we use SPSS for sample size calculation? Okay. I don't know. According to me, only SPSS, we will do the statistical analysis. Okay, fine. Good answer.
Simple size calculator, sir. Simple size calculator available on
Sample size.
online.
Even online, if you search, Google it. For example, if you see sample, sample size estimation calculator. Sir, let me search in Google. Yeah, sample size calculator online. Yeah, sample size calculator.net. Sample size calculator by Rosoft soft inclusion. Okay, we'll see. Yeah, there is one calculator called raw soft. These softwares, and I think that they don't give all kind of formulas, I guess. See, I think here the example which we see, sample size calculator, margin of error you can accept, what is the confidence level you need to, what is the population size, what is the response distribution, then your commencement sample size. Okay, see, when there is a available sample size, let us see one example here. Can you guess what they are assessing here by seeing these values?
Sample size,
Sample size based on
population size, and margin of error.
yeah. Any exam like, is it are they calculating any mean or something called proportion here in this example? Here, percentage, I guess they are calculating some proportion. Let us take margin of error 5%, 95% confidence interval, and imagine you have some 500 participant in that. Like if they are expecting a this is in precision around or estimated proportion around some 20%. See, if you have the certain number of the population, like predefined population size, then you can enter the population size and what is your margin of error and estimated proportion, like how much, if you do the study, what percentage difference you are expecting from your sample to the true population. So out of 500, if you see how much we are getting, around 166. I think I will a bit zoom it. Yeah, now I think this might be good. Okay, when you have the defined population size like that, you can do easily. When you don't have the population size, then how you will estimate? Either you can go with the manual calculation, 2 into z minus 1, 4pq divided by d square, and is equal to 4pq divided by d square. Okay, everybody please note down n equal to 4pq divided by d square. Okay, let me open one PPT, any one PPT so that.
Q means, excuse me, sir.
Yes, yes. What happened? Yes. Yes, ma'am. Please, ma'am.
Sir, is equal to
Yeah.
4PQ. So V for population and Q for ऐसा है?
That I will tell you. Yeah, I'm just searching for the sketch here.
Okay, sir.
It is the sketch we can write right on the slide. Okay, anyway, n equal to 4 p q, small p and q divided by d square, not square, this is square. Okay, n equal to 4pq divided by d square. This is the manual formula to obtain the sample size for the proportion. Okay, n equal to 4pq divided by d square. In this example, see here, what is p here? What is p here? In this example, what is p?
500 population.
P is not population, estimated proportion.
Yes.
So p in this example, p is 20%, like which we are assuming. When you, for example, I told one example, right? How much knowledge the rural people and urban school children are having. If you do the study, you are assuming that there may be some 20% of difference in the knowledge level. Example. Okay, here 20% is the P, and Q equal to 1 minus P. Q equal to Q equal to Q equal to small q. Q equal to 1 minus P. Okay, so in this, then what is D here? T small d. D equal to, I will bit zoom it. Yes, In this example, what is D here? P is 20%. What is D? Margin. What is this? 5%. Okay. 5% is the
5%.
margin of error. You can take this D up to 20%. You can take, in this example is 5% up to 20%. Okay. This P value we can get from the previous studies. P value from previous studies for pilot study we can obtain. Okay. So try to apply this in this formula. D square D into D. Yeah. So 4 PQ divided by D square. This is for estimation of proportion. Sample size for the estimation of the proportion. 4 n equal to 4 PQ divided by D square. In this example, P we fixed 20% and Q equal to 1 minus 20 is nothing but 100 minus 20. How much? 80%. Now you apply. So 4 into 20 into 80 divided by 5 into 5. Four into 20 into 80 divided by 5 into 5. How much you got?
61, sir.
How ma'am?
61, sir.
631. Okay,
Yeah.
let me check. How much you got? 4 into 20 into 80 divided by 5 5 are 25. How much you got?
64.
64.
Yes. 25 point.
25.0. Everybody are getting different values. Okay. Any other answers? I got some different value.
256.
So 4 into 20, right? 20 again into 80 divided by
320.
256, sir.
256.
256.
Yes, sir.
Yeah, 256. Somebody got something different, right? Okay. See, when you don't have the here in this example, see, for example, in this example, we doesn't have the total population size, right? When we don't have total population size, this is the ideal formula to use. But here you see the population is 500. Even they mentioned like what is the population. If you don't know, use 20,000. Sorry, 20,000. Oh yeah, 20,000. Okay, let us see. How much you got? Here, what is the answer?
243.
Almost what we calculated manually is around 250 something, right?
256, sir.
250 something, almost similar, right? See, when you don't have the predefined population, like total population size, we can use this formula, n equal to, this is small n equal to 4pq divided by d square. This is the formula where there is no availability of total population size. So almost we got the same value. When it comes to the one online application raw software, like they mentioned, no, what is the population size? If you don't know, use 20,000. So almost similar we got, right? Almost similar. And one more thing, there is one software called EPI OpenEPI. Have you heard about this OpenEPI?
Yes, sir.
OpenAPI. See here, this is the link
Yes,
for the website link for the OpenAPI. See here, sample size. In the sample size, there is an option called proportion. Proportion is nothing but the percentage. Okay, now we will see whether we did right or wrong. Here, this is the interface of this software. Like there are different options. Let us go with one by one. OpenAPI. See here, enter new data. Here we selected the under sample size. We selected the proportion and enter new data. Okay. Sample size 20,000. 20, right? Yeah, 20,000. What is anticipated frequency here? 20. Then confidence limit is 5%, and design effect. Now we will see. Yes, how much we got?
243.
243 for
Almost
23.6.
similar, right?
Yes, sir.
Yeah. Here to estimate, this is the example where we are estimating, right? We are just estimating the thing. Like we want to estimate the percentage of the proportion of the people regarding their knowledge. Understand? Simple example I am telling. Or percentage of the people who are smoking, percentage of the people who are diabetic. If you want to estimate the proportion of the people who are diabetic, when there is an available of disadvantage of this open here, when you don't have the total population size, we don't know. But as per one software reference, they suggested that if you don't have, use at least 20,000 population. In that scenario, this software is fine. We can estimate roughly, we can enter the data. Sorry, where it is? OpenF, yes. Proportion only, no? An example we did where it went. It disappeared. Anyway, once again we will do. Proportion. $20,000. 20% different, 5% calculate. Yeah, 243 has come, right? When there is a available of total population size, then we can use this formula and we can do. When there is non-availability of total population size, then manually we can go with this formula, that is n equal to 4pq divided by d square. This is actually d square. Okay, d square. This is the one of the formula for estimation of the proportion. For estimation of the mean, we calculated, but here in the software, yeah, there is mean difference. Mean difference formula is there, no mean calculation one. Have you heard about this one, EZR software? Have you heard
No,
about EZR software?
no, sir.
No, this is one of the software which works under R Studio, like R Commander software. You can download also from the internet, but there is a lot of steps to be followed. You please note down EZR for sample size calculation. EZR. E, capital Z, capital R, EZR. This is one of the software where we can use this software to get the sample size calculation. See, just now we saw one example. Let us see. See here, in this software, once you download and install, there are a lot of steps to do. but because of time constraint, but you can try. It's not a big task. You can try. So once you download this software, you will get this interface. One is R console and one is R commander. This is actual interface. Okay. There you can see statistical analysis. Here we have an option called statistical analysis. If you click on this, these are all the statistical, to do the statistical analysis, we have different formulas and options. At the bottom, if you see calculate sample size. Calculate sample size. Now we check the calculate sample size from the proportion and confidence interval. Okay. What is the estimated proportion? We are thinking that some 20%. Here confidence interval width, it depends upon the value, where we can go with 0.1. We'll see how much we got. Required sample size is almost 5,83,901. Oh, this is very huge. 1 second. 0.1, 0.25, we will see. Compromises with the proportion of control, not this one.
Previously, we have chosen the second one, sir.
1 second. Second one, right? This one, right?
Yes, yes, confidence.
Yeah. See, 95%, 20. Okay, 0.20, 20%, and 0.1 is a fixed value. We'll see now. Yeah. Now you see here. How much we got?
246.
246. Here now I just entered as a 20, but we need to enter as a decimals. 20%, 0.20. See, almost similar, right? 246. So this is also one of the software we can use to get the sample size for obtaining proportion. And one more formula we will see. We will see with the see here comparison between two means, two proportions, confidence. This is all mean only. There are two different things. Yeah, sample size for comparison between two means, right? Okay. In one PPT, like earlier session, we have discussed one example, right, about the cholesterol level. Do you remember those values?
I think 55%, sir. I think 55.
Yeah, 1 second. Let me check. One example I said, no, about the cholesterol.
Yes, above
95%. D is standard deviation is 35, and the marginal difference is 20. We will see. Yeah, 65. Remember in the first session, we have discussed one example for independent sample t-test.
Yes, sir.
Yeah, this is the formula. Where is the formula? Sample size for computation between two means. Here, the power we have taken in the example is 0.90%. So 0.90 we need to enter. So alpha is fixed at 0.00. The standard deviation in the example we discussed is 35. And the difference between the means is 20. Then, yeah, 65. Almost matched, right? Like especially when it comes to the RCTs, randomized control trial, the outcome measure, what we are using is the mean, in terms of mean. For example, the average quality of life, the average pain, or average, you can take anything, cholesterol level, or average blood pressure level, or waist circumference, chest circumference, anything. When you want to measure in terms of average, that is mean, this is the ideal formula. Sample size for computation of the mean, independent sample t-test. For RCT, especially when the outcome variable is in terms of measures in terms of mean, that is nothing but the average, then you can go with this formula. 1 second. Sorry for the interruption. I just have written one urgent call. 1 second.
In some studies, sir, there is a question. So, In some studies, they are checking the odds ratio.
Sorry, all. I just have to attend one urgent call. Okay. Yeah, yeah, sir. Somebody is asking one question. Yes, please.
No, sir. Can you proceed, sir, please?
Yeah. Yes. Yeah, we are discussing something. See, this is the disturbance of flow. Yeah, what we are discussing?
About for RCT, we are doing this no, for T test.
Yeah. When there is an outcome in terms of average only, right?
Yeah.
Average.
Mean.
Like when it comes to the proportion, for example, average value is mean. No, sir, I want to compare with the proportion. Like, for example, before pre-test, only 30% of people are having good level of knowledge. Then after post-test, you want to see the proportion of the change or percentage of the change in the average knowledge level. That is called proportion. In that scenario, what formula can be used? Any idea? Proportion, comparison between two proportions. For that also there is a provision. Sample size for comparison between, see here, two proportions. Yes. For example, you did pre-test, you found that there is around 20% of the students or the patients are having some good level of knowledge. Okay. In group 1, and coming to the group 2 also, maybe not much difference, maybe around 0.25% are having some good level of knowledge. Okay, so power is, this is 0.80 power, alpha is fixed. Now we will see how much we will get. The see here how much, 11,000 sorry 1,134 in each group. This is too high. See here how much, 1,134. When you have the difference of around 5%. Let us see. Let us calculate with. Sir, somebody is keep on admitting. Can you admit from your side so that it is disturbing the flow?
Yes, sir. Yes.
Yeah, from your, please. Once again, we will see between two proportions where we will increase the power, and proportion in the group 1 is imagine 0.20, and proportion in group 2 is 0.22. Oh, when you increasing the proportion almost, no, see here, 8,814 sample we need. Okay, what is the trick here? Let us see. When both are same, yeah, it is saying both should not have the similar value. Okay. Mm-hmm. Oh. So proportion, when you are taking very less proportion, we are getting too high values. I guess for this we have one separate formula. Let me explore. Between two comparison between. Okay, non-inferiority. Non-inferiority is nothing but we are predicting that both groups are similar only. Okay, for example, proportion in the control group 0.20 and test group also almost 0.22. meaningful differences in the proportion around to 0.2. Yeah, okay. Here, the like same thing we are using. See here, for example, instead of going with the comparison between true proportions, when you go with the calculate sample size for non-inferiority trial in the sense both doesn't have any difference. Like we are assuming that both groups are doesn't have any differences in the baseline as well as even at the outcome. Like we are saying, we are accepting the null hypothesis, saying that the particular intervention doesn't have effect on both groups. In that scenario, we need to use this formula. For example, 0.20 in control group and 0.10 in test group. Almost a meaningful difference which you expect is 0.10. Then what it is showing something. Proportional 0.20 is 0. Yeah, 56, 58 in each group. So this is the formula where we need to compare, or we need to perform an RCT where we are comparing the where we are assessing the outcome variable in terms of the proportions, in terms of the proportion, in terms of the mean. This is the formula earlier which I said, no, n equal to z minus alpha by 2. Same formula we use. So we got the same value of 65. When you want to assess the outcome variable in terms of the proportion, nothing but the percentage change. In that scenario, we need to go for the calculate sample size for the inferiority. So you may get the doubt, sir, where you collected this value. Proportion in the control group, proportion in the test group. From where we will get this data? From where we'll get this data? Proportion in the control group, proportion in the text group, nothing but the interventional group. From where we'll get data? Any guesses? Any
From
guesses?
previous study? From previous study, sir?
Yes, ma'am. From previous study. So from the previous studies, if you get that too, the previous studies also you need to get a good article, good from the article from the good journal. For example, if you want to go for a PhD level of studies, always try to get a reference study which is published in a good journal, so that you will get the values. For example, any one example, if you take these proportions, you will get from the review of literature exactly those values you can enter. And marginal difference in the proportion, which means like how much difference you are say like you will feel that this will be more effective. For example, 10% difference between the group, you are feeling it is okay, then you can fix as 0.10. Or you may expect that, sir, from the both groups at least 0.20, like 20% of the difference I can say yet it is okay. Like depends upon the proportion, you can decide like how much difference the researcher feel like it is statistically significant, that much difference you can enter. See, for example, from the previous studies, imagine you got one group, they have 30% of good knowledge. Another group, they are having around some 20% of the good knowledge. So like how much difference you are feeling statistically significant, that you can enter. Maybe I am feeling at least 0.5% of difference, you are feeling that this is more than enough, then you can calculate. In that scenario, how much sample size you need? 15 in each group. 15 in each group, is it okay?
No, sir.
Is it okay? 15 in each group.
No.
It is too low. No, not convincing, not acceptable. Then what we can do is we can try with the increasing some difference in the expected difference. So instead of 5, I want to go as a 10. Let us see. Oh, see, if I go with the 10, how much it is coming? 986. Is it
986.
okay? 986 in RCT?
Yes, sir. Might be okay.
986 in each group. almost 1,000 in each group. Is it okay? Yes, somebody please comment on this. 1,000 in each group. Yes, anyone? Anyone comment on this? 1,000 in each group? Yeah, somebody chatted. No, it is 256. No. 1,000 in each group for RCT. Is it okay?
No, sir. It is time consuming, perhaps.
Yeah, maybe it is okay, but you might be having certain target, right? It depends upon the study objective and design and the type of participants which you are recruiting, right? So 956 is too high. Then what we will do is 1,000 is too high. We will try to reduce something expected margin. Okay, same example 0.30, 0.25. See, let us see. Instead of 10, 0.6. Oh, see how much it has come? 9. So it clearly indicates that, see, like we are talking about sample size, sample size, sample size. By seeing this example, what you have to understand, it is a predictive value only, not exact value. Sample size estimation value is the predictive value only. Now you see in front of you only, I changed into 1,000 in each group. By the same time, I converted into 9 in each group. So which you have to believe? Either you have to go with the 1,000 in each group or 9 in each group. Which one you are supposed to proceed? 900 or 9?
As you said, sir, it's depend upon objective of the study.
Okay, 9 is okay. I guess 9 is not okay, right? 9 is not okay. We need to have a better. So, as from the statistician point of view, if you want to make a bigger number also, we can make. If you want to reduce also, we can reduce. So it is also a debating issue. Sample size estimation is a predictive value only. We cannot say it's an exact value, correct, or what is the correct term? Accurate value, right? Accuracy, like that. No, there is no accurate value or exact value. It's just an some predictive calculation for smooth conducting of the study. Okay, see, within seconds I converted into 9,000 per each group, or by the same time I changed it into 9 in each group. See, if you entered 0.6, 9 in each group has come. Let us see. Same value 0.30, 0.25, 0.5%. No, yes, 0.5%. 5% means how much it will come? See, 1.27 in each group. Okay, in this above example, 0.6 is nothing but 60% difference. So that is the reason 9% has come. So instead of that, if you go with the 0.30, 0.25 and 0.10, again 986 has come. So if you want to reduce also, we can reduce, or if you want to increase also, we can increase. So it depends upon the situation or the available of resources or the time boundary. But the thing is, the estimate, the difference should not too high. See, in this example, I mentioned 60% of difference. 60% of difference we cannot expect. At least up to 20% of the difference we can expect. So if I say that 0.09, 1,540, which indicates higher the marginal difference, lower the sample size, or lower the marginal difference, higher the sample size. What is the correct thing here? Lower the marginal difference, higher the sample size, or higher the marginal difference, lower the sample size. In this example, you can see here the difference I kept as 10. That is 10% of difference. If I keep as a 10% of difference, we got around 986. Here, if I keep 0 as a 9%, that is 0.09%, CO 1540. So in this example, lower the marginal difference, higher the sample size I got. Earlier also I mentioned one example. You see, yes, you see here 5%. 0.05 means almost 1.27. So it is changing, depends upon the context. Okay, so you can go with a number of sample, but make sure that you have to keep 3 points in your mind. It should not be too like oversized study or undersized study, and whatever your prediction value should not be too expected, like too high expectation also. You cannot say like my results will be very highly significant, I am expecting this much of change. For example, normally 10 to 20% of change is normal everywhere, but you cannot go with the very high saying that if I perform this intervention, there is a huge difference among the population. That is also risk factor in estimating the sample size. So everything in a minimum way, which is very good. Okay. We will see one more example. Once we saw the proportion, we saw the difference between the two means, and anything which we can go calculate between, yes, calculate between paired means. Any example? What is this test? Calculate sample size between two paired means. What is the test for this? Calculate sample size comparison between two paired means. What is this example?
Paid test.
Paid means. Paid means
Same group. Pre-test.
Paid t-test.
Yes,
Earlier,
paid
between
t-test.
two group means independent t-test.
Dependent.
When you have only one group, right? When you have only one group where you are assessing a difference between pre and post test, that is nothing but the calculate sample size using paid t-test. In that scenario, you need to go with this formula. So imagine if you do the study, you are expecting that there is a difference of some how much mean difference, some 3.5 standard deviation from the previous study. You may got some 2.6 something plus predictive values, and we will see 7 in each group, 7 in each group. Okay, which indicates we need to have a lower standard deviation, or no, higher standard deviation to have a better sample size. So difference between the mean is 0.20 and the standard deviation is 1.5. Imagine, let us say, yeah, 444. Okay, so like that, see, from 7 to it increased up to 444. So we need to have a exact like if you have a accurate example, then we can do the better calculation. Just give me 1 second. I think I have some manual calculation of this. Let me check. This is independent t-test. This is also independent t-test. Yeah, proportion. This is the manual formula for that proportion. Earlier we discussed non-inferiority. This is the manual formula. But it's a bit difficult to calculate manually. So we used the software to get this proportion formula. And independent. Somewhere I saw the paid one also. This is the estimation sample size for the estimation of the proportion. Earlier I saw n equal to 4pq divided by d square. This is also estimation of proportion. This is also independent. Somewhere I kept the folder. I've seen anywhere. Oh, I'm not getting the exact folder. So even manual also there is a formula, but I'm not getting the folder. Sample size. Sorry, I am not getting. Anyway, no problem. So when you have this one, when you want to compare between the proportions, like between the mean between two paid groups, we have a formula called sample size for estimation of the mean between the two paid groups. So then any other formula between the two means, yeah. Frequently, I used to heard one term called like we have a tendency to use one word called sample size obtaining. We will estimate the sample size after power analysis. I think this is the one of the common word people are using. Am I right or wrong?
Yes, sir.
What it is? Power analysis. People use like power analysis, power analysis. Is it correct way of doing? What we are going to analyze? Power analysis, power analysis. I used to heard people write like this in the proposals. Sample size will be obtained by power analysis. According to my understanding, I am not commenting anyone, but according to my understanding, basically power analysis is nothing but the power which we are going to fix, right? 0.80 for the 80% power and 90% power. These two are the most commonly used powers. But people commonly use the term called we can sample size will be obtained after power analysis. According to me, not 100% power analysis will give the accurate thing, but as per the study design and the formula, we need to calculate the sample size by fixing the level of significance and required power, 80% or 90%. Like that, we have to calculate the sample size. Even for your understanding, yesterday I just explored different softwares. Even CMC Vellore. So CMC Vellore, they have a good biostatistical unit. They developed one software called NMaster 2.0. Have you heard about this software, NMaster? NMaster. Anyone heard about this software, NMaster?
No, sir.
No, I guess, right? This is also one of the software which is available, but we need to purchase this software. Like with minimum price, because I didn't purchase so far, but there is one software called NMaster, which is developed purely by CMC Vellore. So they have the software NMaster. If anyone want to purchase, you can go with this software also. And even there is one software called G Power. The options are also very complex. I just explored yesterday. For your awareness, I am telling G Power sample size. www.gpower.huud. Please note down. There are different, so many options are available in this software. G Power. This is the official website of for the G Power. Henrich Heine, I think some other language it is. See G Power, when it comes, just scroll down. Even they provided the manual also how to use the software. Even short tutorial also they provided. When it comes to the download, here, yes. Are you with me?
Yes, sir.
Are you all with me, right? So
Yes,
there is
sir.
a software called G Power. How to download means when you open this official website, come down. Yes, download. There is an option in that you see here. Download G Power for Windows. Those who are using Windows, you can download this. Those who are having the Mac, they can go with this. Since I am using the Windows, I just downloaded this. And once we download, we have to install. Like yesterday I downloaded, see, like that zip file it will come. Compress file, we need to extract the file. So where you want to keep, there you can keep this file. I downloaded and I kept in samples. This one. This is the folder. Once you extract the file, you will get the folder. You need this is the application we need to install. I just installed. Then after this, the second option, G power NT. You need to open the G power NT. I think already, yes. See here, I think it is bit smaller for you to see. There are lots of options. I was so shocked by seeing this software. Here you see, there are tests also, means. We just saw the one or two tests only. You see here, for means only, see how many tests are available. So many tests are available. If you have time, better you just explore each and every option. Test one, see, for example, for the proportion itself, see how many are there. ANOVA, ANCOVA, MANCOVA. For each test, there is some formula. And when it comes to the proportion also, you see McNemus, Fisher extract, jet test, unconditioned text. Since I don't have much time to explore, but I will explore all the options, even means and correlations also, you see here. Correlations also, yeah, everything there is an option. Let us see one example so that you will have an idea. Yeah, we will talk in terms of means. I want to go with the independent, yeah, two independent groups. Okay, two independent groups is nothing but the independent t-test. See, when you click on this, there are, see here, t-test, because we are doing the t-test. In the t-test, we are doing mean difference between two independent groups, where it is changed, I guess. See, once again we will means two independent groups. Yes, mean difference between two independent groups. And this here also there are lots of options, but by default we can go with the a priori. A priori is one of the default option. Now you see here, tail, we need to go with the two tails. Two tail is nothing but the, when you have this probability curve like that, the result may fall either this side or this side, or both sides. That is two-sided. This is one of the concept in statistics. But anyway, by default, you need to select the two test. And see here, effect size. Have you seen this effect size? Yeah. By default, software has given some effect size like zero. See, if you place cursor here, 0.50 medium, 0.80 large, and 0.20 is the minimum effect size. Effect size in the sense, like when you perform, when you do certain investigation, you are expecting some minimum amount of change. That minimum amount of change is nothing but the median effect. And again, this is the constant value, alpha 0.05. And here we can change the power. Either we 80% means 0.80, and allocation ratio is 1:1. We want to have the equal number of samples. Now we will calculate. See here, when you have the power of 80%, and this situation will helps you when you don't have previous studies, like when you don't have any previous literature, or when you don't get the accurate result or accurate review of literature, then you can go with this effect size of this value based on 0.50 or 0.8 or 0.2. So if you use this formula by using 80% of the power, how much we got in each group? Total sample size is 128, and each group is 64 in each group. So this is wonderful because of this webinar, this workshop, online workshop, I explored the certain softwares, but I got this application called G Power. Just take your time, just explore the exploration. When you explore only, you will get an idea. See, lots of tests are available. So for different, I said no, the primary sample size calculation is depends upon the study design as well as study objective. depends upon the data. If it is normal data, we will go for the parametric test. If it is normally distributed data, skewed data, we will go with the non-parametric test. So they have given multiple options. So make yourself free and try to explore this software for the multiple options. So if you keep on talking about, I told now sample size itself, we can have a 2 or 3 days of workshop by using different formulas. But due to a time constraint, I'm just winding the session here. Any questions from your side, you please ask. Yes, anyone? Anything if you want to ask, you can. Am I exceed the time? No, right?
No, sir.
No. Okay, thank you.
Mm.
I hope at least you got some idea or exploration on various softwares which are available. Everybody must try this G Power. See, by seeing the options, I was very shocked. Earlier, for the non parameter like parametric data, we have a certain things, but even they have a option called non-parametric data. Also, what are the various formulas we can use? So many options are there. You can have a exploration. You will get an idea. If you are a master in that, please let me know also. Any questions from your end? So with this, I am going to conclude that sample size estimation is not an accurate thing. It might changes, depends upon the need of the investigator and depends upon the situation also. But we need to consider our estimation also, like we cannot go with the very high-end estimation because always the minimal or medium level is the better option. And for obtaining these values also, you need to have a previous review of literature. So nothing good or nothing wrong or right in the sample size estimation. But only thing, you need to keep these things in your mind. One is your primary objective, the main objective, primary in the sense, what is your main outcome variable? Is it in average form you are saying, or it is in the proportion form you are going to say? And the study design also to be considered when you are obtaining the sample size. So that's all from my end. Thank you for your patient listening.
Thank you, sir. Thank you very much, sir.
Any questions, please?
Chat box. Check the chat box.
Any questions?
Any chat?
Any questions from the participants?
I guess no questions, which means I think most of them. What is the R software? Acha, R software. Somebody. So for learning sample size will take a lot of time. For me, at least to understand until this, it almost took 4 to 5 years to get the concept. So it is not a one night or one day learning. It is a continuous learning. So you keep on practice or explore various softwares and all, definitely you will be mastering in sample size calculation. And thank you for once again for the event organizers. Thank you so much. And thank you so much to made me to be a part of this wonderful webinar. Thank you.
Thank you, sir, for delivering such an informative demo on the various software tools used for sample size estimation. This session will undoubtedly help us in making more informed decisions in our research planning. We deeply value the time and dedication you've invested in making this session enlightening and enriching for all of us. Thank you so much, sir. So now moving forward, RCTs are the gold standards in research, but evaluating their quality is essential for reliable conclusions. I welcome our esteemed expert, Dr. Rashmi Venkatesh ma'am, for guiding us through the process of critically appraising randomized controlled trials, that is RCTs. Her expertise will provide valuable insights into evaluating RCTs effectively.
Yeah, sure. Sure. इधर नहीं है. Stop sharing. नहीं.
Dr. Rashmi Venkatesh, ma'am, professor in HOD, Oral Medicine and Radiology at KM Shah Dental College, has 16 years of academic experience and holds a BDS and MDS in Oral Medicine and Radiology. Ma'am has published over 41 research papers, contributed to 4 textbooks. Dr. Rashmi is ethics committee member of Integrated Health Sciences. Ma'am has been invited as a speaker and trainer in evidence-based practice areas. So now we are going to start our session regarding RCTs. Over to you, ma'am.
Screen visible, ma'am. Yeah.
Good afternoon, one and all. Myself, Dr. Rashmi Venkatesh, Professor and Head Department of Oral Medicine and Radiology, KM Shah Dental College and Hospital. Sumandeep Vidyapeeth University. Before starting the session, I would like to thank the organizers, Dr. Anita ma'am and Suresh sir, for inviting me to share my knowledge regarding the evidence-based practice. So today I will be briefing regarding critical appraisal of randomized controlled trials. So as we all know, randomized controlled trials in the pyramid of evidence-based practice, that is, it is in the top with respect to the primary level of evidence. So as we all are aware that basically the evidence, the literature, whatever is available is divided into primary and secondary evidence. And the primary evidence is basically the original studies or the original articles. So which includes starting from the case reports, case series or cohort studies, case control studies, cross-sectional studies, and randomized control trials. So, with respect to the primary evidence, that is the original studies, the randomized control trials are considered as the top in the pyramid, because there are very less chance of bias, because in the context of such research, mainly due to the robust methodology. I'll be coming to that later, what will be the methodology here with respect to randomized control trial. And above this primary evidence, we all know systematic review and meta-analysis that makes the secondary evidence, where the data from the primary evidence will be pooled, and the pooled effect will be drawn, and a single answer to particular questions will be given. Okay, so that will be the secondary evidence. The randomized control trial is considered as a highest level with respect to the primary evidence. Above randomized control trials is the systematic review and meta-analysis. And also with respect to evidence-based practices, now there are even the databases where the secondary level evidence synthesis will be done, like Cochrane queries, or this thing, or pre-appraised abstract like synopsis, summaries on the evidence-based textbook, etc. will be given. All those synopses which are graded or pre-appraised all fall under secondary evidence. So basically, I'll be explaining how to critically appraise the randomized control trial article. So there are 5 basic steps in evidence-based practice. The first one is formulation of a question. So wherever the clinical query occurs, the researcher or a clinician will formulate the question in the form of PICO, that is PICO, where P stands for population, I stands for intervention, C stands for comparator, and O stands for outcome. Once a clinician is framed the question, that is answerable question, in the PICO format, the second step is to search for the articles. The basic steps will be there for searching, which can limit the search, because searching in a Google will lead to thousands of articles or thousands of reports, which is humanly impossible to read all those. So systematic way of searching is actually the way to limit our search, where we will reduce the number of answers what we are gathering. This thing. Once the search is over, once we have gathered the articles, the third step is what is the topic for today, that is the critical appraisal. Okay, so what is critical appraisal? Critical appraisal is the process of carefully and systematically examining a research. Why we want to carefully and systematically examine a research? Because we want to know its trustworthiness. We want to check its trustworthiness, its value and relevance. I'm really sorry. Okay, so we want to check the trustworthiness of an article, because we want to use the results of the article to make a decision. Why we want to make a decision? We want to make a decision so those results can be applied to our patients. Okay, so there are many other definitions. According to Cochrane glossary, we have to appraise an article to check its validity, results, and relevance. That means indirectly to check the trustworthiness. Okay. So the validity, the internal and the external validity, the results and the relevance of an article to our patients has to be checked before we accept that article to be trustworthy. Okay. So this is main step to make a decision. We will read the article, check the article carefully, critically appraise it, and we will decide whether it is good enough to be used in decision making. So as I told you, after formulating a question and after going through a thorough search, the third step of evidence-based practice is critical appraisal. So why we need to critically appraise? Why can't we just accept their results and apply it on our patients? Because we don't know how a researcher has carried out the research, whether there was some bias or not. So there, in an article of BMJ, it was told that a 21st century clinician who cannot critically read and study on an article is as unprepared as one who cannot even measure a blood pressure. That means any healthcare student or healthcare professional who is unable to critically read an article means he's unable to take a blood pressure, means he's as dumb as that. That means it is a basic requirement as a healthcare professional that we all should critically appraise an article. We should not blindly believe any scientific article without appraising it. So we will see what is actually critical appraisal and what it is not. Critical appraisal is to find the validity of the study. That means whether their methodology is robust or not, whether there was bias or not, and also to find the reliability of the study, means whether their results, what outcomes they had checked, and whether they are credible or not. And the third one is to find out the applicability, means their patients and our patients are similar enough that their results we will apply to on our patients. Okay, so these are the three reasons why critical appraisal is done. And critical appraisal is not just negative dismissal of any piece of research. We cannot dismiss any research without critically appraising it. If we find after reading, after appraising, that so much of bias was there, the results are not relevant, then only we can dismiss that research. Okay, and critical appraisal is just not assessment of results alone. The main important body of a research is methodology. So just don't jump into results and see their results. What is their results? We have to see what was their methodology which has led to this result. Okay, and critical appraisal is not entirely based on statistical analysis. It is, yes, the statistics plays an important role based on their what outcomes they have measured, but it is just not depending on whether p-value has come significant or not significant, because so many times there can be statistical significant results which may not be clinically significant. So even the statistical significant results we cannot apply on our patients because it is not clinically significant. And critical appraisal, there is a notion that only experts can appraise an article. It is not so, because various evidence-based practice organizations have made it so clear or so easy for anyone to critically appraise. We have a checklist. Almost every evidence-based organizations or even the normal academic organizations have their checklist where the questions will be given. So we need to read an article and then answer the checklist. We have to tick on the answers and then we'll come to know whether the article is trustworthy or not. Okay, so this is the basic gist of critical appraisal, why we are performing critical appraisal. So in my first slide, I had shown the evidence pyramid. So in that primary evidence, as I told you, here the body of evidence consists of original individual studies, means the trials, the RCTs, the cohort studies, the case studies, etc. So these are also called as unfiltered evidence. The primary evidence is always called as unfiltered evidence because the reader has to read it and then make a decision. So these are unfiltered evidence. Okay. So this primary evidence, what are the important things here? Here the data gathering is actually fresh. The author would have conducted the research and he would have collected the data by himself. That is, the researcher himself is involved in collecting the data, and according to specific inclusion and exclusion criteria, the data collection will be done. The recruitment is based on that and the data collection is like that. And such kind of studies require a long time, and it will cost more, and the data will be recent, and to the particular new context, the specific data will be available. And this can be of three types. That is, it can be exploratory, experimental, or ethnographic primary researchers. Exploratory research means it is a hypothesis based, where the researcher always is trying to prove the null hypothesis wrong. Okay, experimental research is a quantitative research designs, and ethnographic research is a research which is carried over a period of time where the observation is done. Okay, so examples of primary evidence includes randomized control trials, cohort studies, case control studies, case series, and case reports. Okay, so randomized control trial, that is what we are focusing today. So these are the carefully planned experiment where the efficacy of any type of treatment or a therapy is checked on a real patients. Okay, not on guinea pig or rat or other things. Here on the real patients, the efficacy of a drug will be tried. Here the methodology is very strong, where the randomization and blinding will be done to reduce the bias. That means the result is not by chance. It is actually because of the effect of the drug. Okay. And then here it will allow for the comparison between the intervention and the control group. The control group can be another drug or a placebo or no intervention, etc. Okay, so this is a strong research design which will provide a sound evidence for cause and effect. So we should, whenever we are reading an article and critically appraising an article, we should know the structure of an article. So article, I think almost all of us know the structure. So I will quickly, briefly tell the structure of an article. An article will have title. Title, please always don't go by title. It is not always a good indication of the content of the article. Just reading the title and dismissing an article or accepting an article is not acceptable. Okay, so we have to go through the article. Okay, after title we'll be having an abstract part. There are two types of abstract, that is structured and unstructured abstract. Basically, abstract is a summary of the research question and the key methods, result, and conclusion. So it can be unstructured, which can be given in a paragraph, or a structured where the subheadings will be given. The next part will be introduction. Introduction in an article, a researcher and author would have explained the background of the study, and also he would have pointed out the research gap in that particular subject and explained the PICO of his research. That is the question, research question. So what hypothesis is being tested will be explained in the introduction. Okay. So next, a little bit of background and review of the literature will be done, where the rationale of the study and the research gap will be explained. Okay. And next, the research setting, the organization context where this research was conducted, etc., will be explained. And the next part is the methodology part, where the researcher or an author has explained about the sample calculation. I think just now you have finished with that session of sample calculation. So where the characteristic selection, number, non-response, etc. will be there. And the study design, the procedure, what type of study design they have adopted, whether it's a qualitative, quantitative, or a controlled trial, etc. will be there. And after they have explained in results, the outcomes, the findings will be given, and all the outcomes with the confidence intervals, where we can find the effect size, will be presented in the result. So appropriate biostatistics will be applied there, and the confidence intervals, the effect size, etc. We can find the answers for those questions in the results. Later in the last part, that is the discussion, the author will be interpreting his own research results, and he will be comparing those results with the other studies, okay, which is already existing in the literature. And also he'll make a note of weakness or limitation of the study, and the further implication of his research, and also the further recommendations, whether further studies has to be done, or this is the drug, we can start using it. All those recommendations will be given. So this is the basic structure of an article. So any article, even the randomized control trial article also, will be having the same structure. Coming to the study design of randomized control trial, this is not a research methodology lecture. So only briefly I'll be telling what exactly happens in randomized control trial. Okay. So there will be a set criteria designed by a researcher, where the selection criteria includes inclusion criteria and exclusion criteria. So based on that, the eligible population will be selected, and whatever the outcomes has to be measured at baseline, it will be measured. Okay. So after that, that group of population, eligible group of population, will be divided into two groups. One is the trial group and the other one is the control group. The trial or the treatment group and the control group will be divided randomly. It is without any kind of bias. So random division can be by various methods like block randomization, simple randomization, computer generated numbers, odd and even numbers, or a fishbowl technique. So there are various methods of randomization, but the computer generated randomization using the software is the best method for dividing the patients in RCT. Okay, and then after the division of patients is there will be blinding. Even the patient will not be knowing actually whether he is in a control group or the treatment group. Neither the clinician will be knowing which group is what, and only to the treatment group the essential treatment will be given. And the end of the follow-up, it can be 1 year follow-up, 6-year follow-up, 6 months follow-up, or multiple follow-ups. The outcome measurement will be done, and then there will be evaluation of that data collected during the outcome measurement. So this is basically the methodology of randomized control trial. Okay. So here, randomized control trial, as I told you, is top when it comes to primary evidence, because the chance of bias is less. because here randomization is happening while selecting the eligible patients. So there will be no allocation bias or a selection bias. So, but if there is failure of randomization, then the systematic differences will be there in the both groups, that is the treatment group and the control group. So there will be allocation bias. And in randomized control trial, or for that matter any research, there should not be any systematic differences in the intervention received by the both the groups. That means only the drug which is being tested should be different in the both the groups. Other than that, whatever treatment has been tried, whatever treatment is been given, even the educational interventions se leke, even for pain thing or for some comfort, for some lifestyle, if some interventions has been given, that has to be equal to the both the groups. So if it is not equal, then there will be performance bias. The third one is usually when we calculate the sample size and decide the final sample size, we always consider a 20% dropout and we increase the number of samples before starting a trial. Because since we are checking the efficacy of certain drug over a long period, we need to have follow-up of the patients. So if there is any loss to follow-up due to non-compliance of the patient, or loss to follow-up because of serious adverse effect, or loss to follow-up because of death of the patient, there might be many reasons for the withdrawal of a patient from this thing. So it should not be more than 20% of withdrawal. If it is so, then there will be attrition bias, because the results, the patient who started the trial are not responsible for the result, because there is so much of attrition during this period of conduct of the research. Okay. Next one is detection bias or measurement bias. Usually this does not occur with respect to randomized control trial, just because there is blinding and concealment. If there is no blinding and concealment, that means there will be obviously the systematic differences in the outcome what we measure. That means there will be detection bias. So to minimize the detection bias, blinding is very important. Okay. And with all this also, certain confounding factors can be there, where there will be, which leads to differences between the two arms, that is the control arm and the treatment arm, which can lead to a difference in the outcome measured. So always the baseline characteristics, the prognostic factors, the concomitant interventions, everything should be same. And the researcher has to mention that in article. Okay. For a factor to be confounder, it must differ between the comparison group and predict the outcome of interest. Sometimes certain factors may not be affecting actual outcome. That means those are not a confounding factor. Okay. So this was regarding the basic structure and the basic design of randomized control trial. Now we will come to critical appraisal of randomized control trial. As I told you, critical appraisal, for appraising an article, first thing what we have to do is we have to read the article. Once we read the article, how we'll appraise, we might forget few points, and we might actually remember only few points. To remove this confusion, we already have the checklist. There are various checklists available freely online. This thing, you can go to any evidence-based organizations like Jonas Briggs institution, that is JBI Australia. You can download for the checklist, or you can go to CBM Oxford Library, where we can download the checklist. So once we read the article, we have to tick answer the questions which are there in the checklist itself. So today I am giving an example from the checklist taken from CEBM, that is Center for Evidence-Based Medicine, Oxford University. So the reason it is whichever organization, whether it is John Hopkins University or Sumandeep Vidyapeeth or Oxford University, the almost all the questions are same with respect to the study designs. The checklist questions will be same. The reason I have taken this checklist, that is the CBM, because they have explained in the next section only exactly where to look for the answers. So for the beginners, what I suggest is always go for CBM checklist, because if you get stuck somewhere, like where to find answer for this particular question, it would have been explained in the checklist itself. Okay. So basically the checklist, we have to answer three categories. That is whether the results of the study is valid, are the results are clinically useful, or the results applicable to my patient. Okay. So the first part, whether the results of the trial are valid. When will be the results of the trial valid? If they have done the experiment without any bias. That means their methodology, whether the methodology is strong, that means the methodology is without any bias, means the internal validity of that particular research is very robust. Okay. So the first question is, what question did the study ask? Means what was the researchers' research questions, their PICO, patients, intervention, comparison, and outcome. What were the patients, what were the interventions, what was the comparison they have used, and what outcomes they have exactly measured, whether it was the quantitative outcome or a qualitative outcome, etc. Okay. And sometimes even the time period can be added, that is PICOT, for what period of time. So the answer for this we will get when, as I discussed in the structure of an article, the researcher's PICO will be explained in the introduction part of an article. So when we are reading the introduction, the author would have given the research gap and his research PICO. Okay. So that we have to mention. The next question is, was the assignment of the patients to treatment randomized? Okay. Randomized means the selection of a control arm and the treatment arm is random. So the best method is the centralized computer randomization, which is very ideal for the RCT design. Okay. So the answer for this particular, we will be getting it in the methodology section. So towards our right hand, where to find the information, this explanation is been given in this checklist. So okay, that is the reason I told you, for the beginners, it's always better to use CEBM checklist, because if you don't know where to find the answers, they have clue given there. Okay. So the information of randomization, it is given in the methodology section. So in methodology, what kind of randomization was, how the patients were allocated to the groups, and whether the randomization was concealed or not will be given. Okay. So concealment helps in blinding. So usually the concealment will be in the treatment, whatever has to be given will be within the white opaque envelope. So whoever is giving that envelope also is blinded, whether the patient is in the control arm or on the treatment arm. Okay. So for every question in this checklist, you have to answer the checklist. You have to just tick only. There will be three options, that is yes, no, or unclear. So if the randomization has been done, you can tick on yes. If it has not been done, you can tick on no. If they have not mentioned Sometimes they will just mention it's a randomized double-blind study. But what kind of randomization they wouldn't have mentioned. So the reader will be always confused whether they have actually done the randomization or not done the randomization. So in such situation, you can tick it on the unclear part. Okay. So, and you can write a comment there why it is unclear. Okay. Next question is, were the groups similar at the start of the trial? Okay, so whole idea behind the randomization is we want a balanced two groups. We want balance with respect to the disease severity. We want the balance between the age group of the arms, and we want a balance between distribution and male and female. We want the balance between their economic status, their geographic location, so everything. So basically, if the researcher has done the randomization, the baseline characteristics will be balanced. Okay, so that is the reason before randomizing, the baseline outcome measures will be actually taken once, and the answer for this will be given in the result section. So where do I find the information for this? The results. Usually the baseline characteristics of the groups along with the p-values will be given in the result section, or as a baseline characteristics table. Usually it will be table number 1. Okay, so if both the groups were same, then tick it on yes. If it is not same, no. And if they have not mentioned, then click on unclear, and then you can write your comment. Next question. Aside from the allocated treatment, were the groups treated equally? Okay. So this is what I was telling previously. Only difference between the control arm and the treatment arm should be the treatment itself. If it is one treatment, one drug they are giving and a placebo they are checking, only that should be the difference between the groups. Rest all measures what they are taking, whether they are giving fever medicine along with that, whether they are giving some IV fluids to the patient. So all the other things should be equally given to both the arms. Okay. So again, where do we find this information? We find it in the methodology section or result section. So the researcher has a freedom wherever he wants to mention it, they can mention it. Okay. Again, 3 options will be there. Read the article. According to that, you can tick it on yes, no, or unclear. Okay. The next question is, were all the patients who entered the trial accounted for? That means whether they were analyzed in the groups to which they were randomized. Okay. So during sample size calculation only, if the researcher has calculated loss to follow up and increase the sample size, and later loss to follow up is there, then it is fine. So imagine if sample size is small and there is loss to follow up for various reasons, then every patient who entered the trial should be analyzed at least by intention to treat analysis. For example, if it's a 1-year follow-up study and some patients have come only till 7 months, some patients have come only till 6 months, and some have actually come till 1 year, then just don't exclude the patients who have not come till 1 year. So instead of that, statistically we can use intention treat analysis and make sure that the results of those patients who did not complete their follow-up can also be used. Okay, so the results we will be the answer for this will be given in the result sections, like how there will be usually a flow chart also with respect to RCT articles, that is called as consort flow chart, where the randomization, allocation, and the treatment given and the follow up, how many were lost to follow up, the reason for the loss to follow up, etc. will be given. Theoretically they would have written in a text also, and sometimes if a consort flow diagram is there, it is easy for a reader to check. We can just go through the consort flow chart and find out how many loss to follow-up was there, whether they all were considered in the statistical analysis by intention to treat analysis. All those things we can check and we can answer our question with as yes, no or unclear. Next question is about the blinding. That means were measures objective or were the patients and clinicians kept blind to the treatment being received? Okay, what is ideal? It's always ideal to have a double blind. Means the investigator and patients should be unaware. Okay. If the outcome objective is death, then blinding is less critical. Imagine like we are giving a life-saving drug, whether it will save the life or patient will die, this thing, then blinding is less critical. If the outcome is subjective, like symptoms, reduction in the fever by 2 degrees, by 3 degrees, like that, then blinding of assessor will become very critical. The assessor should not know whether he or she, the participant, belongs to control group or the treatment group. Okay. So even sometimes if the treatment administration is two different ways, for example, one patient is getting laser excision of some skin eruptions and other one is getting just a topical cream, then obviously blinding to the patients is not thing, but only assessor can be blinded here. So in such situations, single blind is okay. But if it is ob subjective evaluation, mostly, then blinding, double blinding is must. Okay. So where do we find this information? Definitely in the methodology section. The methodology where the blinding, the placebo group or the no treatment group, how they have blinded. Sometimes there will be even sham control where the dummy instrument will be just shown to the patient as if they are receiving the treatment. That is also kind of blinding. Okay. And also the outcome what they have measured also will be explained in the methodology section. And the investigator, if they are blinded, whether the assessor is blinded or not, will be explained in the methodology section. So for this question, we will get the answer in the methodology section. So read the methodology section carefully and answer it as yes, no, or not clear based on the article. Okay. So next, that is regarding the internal validity, means the robustness of the methodology. Okay. So those questions, whatever I have discussed in the checklist is for internal validity. So there are almost 6 questions or 7 questions. If S, we have ticked S for almost all questions, means it is a robust methodology. Very good internal validity of that article is there. But if there are 1 or 2 no's or unclear, that means we are doubtful their methodology was robust. The results what they have obtained is because of the bias, whether it is by chance, we will have a doubt. Okay. So that is about the internal validity. The second part is reliability. That means what are the results. Okay. So first question is how large was the results? That means the effect size. The effect size means the 2 groups are there. For example, we are checking the decrease in the body temperature or a fever by 2 body temperature. The effect size, whether it is the difference is 2 degree or it is 1 degree and or it is like 5 degree within 1 hour, like that. Okay. So out like if we are checking for long-term results like cancer recurrence or MI or death. Okay. So it is like consider a study where 15% of control group died and 10% of treatment group died within 2 years of treatment given. Okay. So such results the researcher can express in many ways. So how they have expressed, usually it will be there in the tabular form and very briefly they would have explained in the result part also. For example, they can explain it as a relative risk, that is the risk of the outcome in the treatment group, or in the risk of the outcome in divided by the risk of the outcome in the control group. Okay, so that means what exactly it means? It tells how many times more likely is that an event will occur in the treatment group when we compare it to the control group. Okay, if relative risk is less than 1, the treatment decreases the risk of whatever outcome. Here they have given the example of death. Okay, so or they can express with risk ratio also, which is calculated by risk of outcome in the control group minus risk of outcome in the treatment group, and this is also known as absolute risk difference. Okay, if it is 0, that means there is no difference between both the groups. So you give the treatment or don't give the treatment, the patient is going to die. Okay, that is what, or the symptoms are not going to get subsided. Okay, or they can express it as a relative risk reduction, that is absolute risk reduction divided by risk of outcome in the control group. Okay, so the treatment reduce the risk, how much, by how much percentage will be explained. Okay, and also number needed to treatment. This is inverse of the absolute risk reduction and is calculated as 1 divided by ARR. Okay, means how many number of patients we need to treat in the experimental group to prevent at least one outcome. For example, if we give polio drops to 100 kids, at least one polio occurrence we are preventing. Okay, so this is just an example, that is number needed to treatment. So based on the outcomes what they are measuring, the results will be expressed in many ways. Okay, it can be relative risk, absolute risk reduction, number needed to treat, that depends on the outcome. So answer for all this we will be getting in the result section. Okay, next question for reliability is, how precise was the estimate of the treatment effect? Means their point estimate, that means the confidence interval and the p-value comes almost every time. The researcher statistician tell to take only 5% chance, means only 5% of the result is by chance, but 95% he is confident enough to tell the result whatever they have obtained is because of the treatment what they have given. Okay, that means the p-value is less than 0.05 level or 0.05%. So if the p-value is less than that, there is a significant difference between the treatment group and the control group, and the treatment is very effective control to this thing. If it is more than that, the p-value, that means there is no significant difference between the treatment and the control group, so there is no extra effect of the treatment. Okay, so that was the second step of the critical appraisal, that is the reliability. So all the answers for this we will be getting in the result section. So please read the result section and tick the appropriate boxes as yes, no, or not clear. Okay, the third part will come only if we have a good internal validity and a reliable results. So if all the checklist boxes are yes, 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 yes in the first section with very minimal no or no nos, and reliability is very good, then only we know now their results is actual result, not by bias. Now we want to make a decision. Now we want to try that particular treatment to our patient. So that is decision making or external validity or applicability. Okay, so here 3 questions we are supposed to ask to ourselves, that is whether my patient is so different to those in the study. That means, for example, treatment treatment of some mucosal disease which occurs like autoimmune disease, which and the study is done in UK. And we are reading that article, very good article, very new treatment. It is fantastic results has been given. So same similar patients, autoimmune disease, if a patient comes to me, definitely I can give the same treatment because the pathophysiology of the disease is same, whether the patient is in US, UK or India, right? So there is no difference between the patients. But similarly, if they are treating some lifestyle modification of UK patients and they are suggesting, okay, you are supposed to get up early, you have supposed to drink broccoli soup and this for your lifestyle, that I cannot apply to my patient from a rural setting or from a background where the entire lifestyle is so different. Okay. So first question is that whether my patient is similar enough to apply this result or so different that I cannot apply this result. And if we can apply that results, next thing we will be asking is whether the treatment is feasible in my setting or not feasible. Okay. So feasibility, for example, even with respect to my patient's affordability, whether my patient can afford to this new treatment or whether the gold standard or the old treatment only is fine, though the new treatment is more effective, because it is not feasible, it is not available in my setting, it is not available in Indian setting, or if it is available also, it is so costly that my patient cannot afford this patient. The third question is the risk versus benefit ratio. Will the potential benefit outweigh the potential harm of the treatment for my patient? Okay, we have to evaluate that. So based on this, we will be making a decision whether to use the treatment to my patient or not to use. Okay. So with this, we'll be finishing the critical appraisal, this thing. So basically, if it is, when we read and critically appraise, if it's an unreliable and invalid article, we cannot use that results. If it is a valid results but unreliable, means they had so much of bias, selection bias and all those things, then again we cannot use. If it is reliable and not valid, again we cannot use the treatment. Means if we want to make a decision of using those treatment, means it should be both reliable and valid. Okay. So Center for Evidence Based Medicine has given the levels. So if it is a well conducted RCT, it goes to highest level, it is considered as level 1B. Or if it is a low quality RCT, that comes down to 2B, that means the quality of the evidence, though it is RCT, it is not good to be considered as level 1. Okay. And also, when grading the quality of evidence, we will grade it as high if it is a good RCT, if it is low or very low. So this completes the critical appraisal. I'll just ask the organizers whether we have time so we can go through any article. Okay, the organizers have downloaded one article. I'll just show you the article, like where exactly you have to look for the answers of critical appraisal questions to check the internal validity, reliability, and external validity. Okay, so this is an article of effect of carica papaya leaf extract capsule on the platelet count in patients of dengue fever with thrombocytopenia. Okay, so here the PICO is the patients having dengue fever and thrombocytopenia. Okay, P stands for the patients of dengue fever with thrombocytopenia. Okay, and the intervention what they are giving it here, papaya leaf extract capsule. Okay, and the comparison is no papaya leaf extract capsule, just the normal care, and the outcome they are checking is the platelet count, whether it is increasing or not. When we go through the article, we'll also come across whether they have checked how many times the patient needed the blood transfusion, means number of blood transfusion. So that this is the outcome they are checking. So the PICO, we will, when we read the introduction, so here the introduction part is there, where they have given the background of the article, and also background of the papaya leaf extract they have given, and they have told the inclusion criteria of the patients like above 18 years of age who could give the informed consent, and and the this thing. Okay, so the PICO, we will be getting the answer in the introduction part. In the material method part, when we see exactly the inclusion criteria is given, means what patients they have taken. So above 16 years of age, they should be serologically proven they should have a dengue fever, and also either by NS1 or IgM antibody, and those patients only who have thrombocytopenia, that means platelets less than 1.5 lakh per cubic millimeter. Okay, this was this thing. And then the method of randomization also they have explained. They have done a simple method of randomization, that is odd even method. So based on that, all the odd number patients were given the treatment, and non this thing, that is even number patients, no papaya leaf extract. Okay, so other than that, the supportive treatment was routine, where the normal saline, antiemetic drug, and paracetamol as an antipyretic drug was given. And every time they used to check the blood counts, platelet count, hematocrit level, and whoever required the blood transfusion because of decline in the platelet cells, the blood transfusion number of times required, they have given. So these all are the answers for the internal validity, but here they have not mentioned whether there was blinding or not. That means for that question there will be one no for the answer. And the results they have checked how many platelet transfusions has been taken, and also average days of hospitalization also checked in both the groups. These are the two outcomes they have checked, and the answers are given both in the tabular form and also in the result section, and the comparison has been done by student t-test. Their results, that is the reliability of the result, they have using the biostatistical method. Okay, and then in the discussion they have explained their results compared with the previous results. So according to their research, conclude that the in dengue fever, and also they have not found major side effects, and also they are thinking that like just along with the supportive care, if we gave this papaya leaf extract, the risk of thrombocytopenia will be reduced. So, and this is a randomized trial which was done in India. So the third part, when it comes to applicability, so since it is done in India, the drug is available in India, so feasibility is not there. The patients are similar. Dengue fever everywhere in India is same only. The cause for the dengue fever is same virus. So the patients are similar. The drug is available. It is feasible. We can. There are no adverse effects. So even the applicability is positive. Okay. So this is example of this thing. So you can go back and download the checklist. It is not hard and fast rule that you should follow always CEBM checklist. The questions will be almost same. You can follow any checklist. If you have 2-3 checklists, you can make your own checklist by adding some questions, mainly to increase the robustness of this thing. Okay. So with this, I conclude my presentation. If any questions are there.
No, ma'am. Thank you.
Okay, thank you. I'll hand it over to the organizers. Thank you.
Thank you so much, Dr. Rashmi Venkatesh ma'am, for such an informative session on the critical appraisal of RCT. We sincerely appreciate the time and effort you've put into making this session both educative and valuable. So now it's time for the lunch break. So we'll meet at 2 o'clock after 1 hour for the next sessions. Thank you all.
We will be resuming this session in another 5 minutes. We are awaiting others to join. We'll be resuming the session in another 2.
देखो जा रही को बोला
Very good afternoon to all. I welcome you all after a short break. So, am I audible to all?
Yes, madam.
Am I audible? Okay. So now we'll begin with our next sessions. So now I'm pleased to welcome Ms. Bhumika Patel ma'am for delivering information on today's session of normal distribution of sample. Ma'am will guide us through its fundamental concepts, significance in statistical testing and interpretation. So first, I would like to highlight some credentials of ma'am. So Ms. Bhumika Patel ma'am, MSc Nursing, is the assistant professor in the Department of Medical, that is Psychiatric Nursing, in Sumandeep Nursing College, Sumandeep Vidyapeeth University, Vadodara. She has completed her undergraduation from Choitwan College of Nursing, Indore, and post-graduation from Sumandeep Nursing College, Vadodara. Ma'am has 1 year of clinical experience and 8 years of academic experience. Ma'am has authored and co-authored over 35 articles and 9 book chapters and has registered 2 copyrights. Now we are going to start with our next session. Over to you, ma'am.
Okay, good afternoon, all of you.
Good afternoon, ma'am.
Good afternoon, madam.
Okay, so starting with this lecture, I know after lunch I'm going to take this lecture. It's to please give your few minutes attention. It will be really interesting. So first of all, good afternoon, respected principal ma'am, all the faculty members and my dear students. I want to thank our principal ma'am to giving this wonderful opportunity. Am I audible?
Yes, ma'am.
Is it audible? It's audible, sir. Okay, so I'm starting with this lecture. Good afternoon, principal ma'am, all the faculty members and my dear students. So first of all, I want to thank principal ma'am for giving this wonderful opportunity to speak on this platform. Since morning, I think you are playing a wonderful role. Here in nursing also, we are playing a role of nurse as a researcher, right? So since morning, you are playing this role. That is wonderful. But one quality is there of researcher, if you have heard, that is motivated. Always the researcher must be motivated, then only the good quality of research he or she may conduct, right? So for a few more lectures, for a few more 2 lectures, please keep motivated yourself and gain some basic knowledge. Okay, so today's my topic is normal distribution of samples. So before moving to this topic, normal distribution, the word correlated with this distribution, that is probability. So first of all, we are going to discuss about what is probability. Might be you have heard this word normal probability. What do you mean by normal probability? Here you can see the probability is the chance of occurring of an event. Okay, but whatever event is happening, you are giving some estimation that this thing will happen at the end of the result. That's what we can consider as a probability. But probability may happen only for the possible event. For example, if I am giving you, everyone knows that sun is always rising from the east and having a sunset on west. Okay, so this is the natural phenomena. You are having only the one option. It will rise from east only, not from west. So in that case, you cannot go for probability, right? When you can go for probability, when you are having any options of answers, in that case, you can go for probability. Here you can see I have kept few example. The first example, that is flipping of coin. Okay, so whenever we are flipping a coin, there is two possibilities. Either it can be head or it can be tail, right? So suppose if you want to check the probability of having head, here you can see this formula. The probability of head is equal to favorable number of events divided by total number of events. Here what you can consider as a favorable number of event, that is your answer. So definitely whenever you are flipping a coin, there will be only one answer. Either it can be head or it can be tail, right? So here you have to write it down, that is 1 divided by total number of events. What do you mean by total number of events?
Total number of event, that means options you are having. Here you are having two options. Hey, either it can be head or tail. So you are having two options. So here in this formula, you can keep 1 by 2. So 1 by 2, that is your 50%. So 50%, we can say that 50% chances are there that there may be head will come in the answer. Okay. So how you can reach to your probability? Suppose if you are having only one coin and you are flipping it 3 times. Okay, is it, or 4 times? Is it possible? Suppose you have done the probability and you have found that 50% probability are there of having head. Suppose 4 times you have flipped the coin. Is it possible that every time or half of the time it will come head? No. Okay, all 4 times also it may come for tails, right? So when you can increase this chance, when you are having more coins. If you are having 2 coins, there will be a 4 possibility. If you are having a 3 coins, you may have a 8 possibilities, right? So how I am correlating here, that is in research also, if you want to reach out your probability, what you have decided, you must have a more samples, what I mean to say. Okay. The second example you can see here, if you are having this dice, so this dice has also 6 parts. Okay, 6 possibilities are here. 1, 2, 3, 4, 5, 6. Suppose if you want to find it out the probability of 3, that how many times this 3 number will come. So how you can calculate here the favorable number of event, that is answer only will come 1. Okay, one answer only can come. So here 1 by 6, because 6 possibilities are there. So 1 by 6 is equal to 0.16. So 16
Can you speak?
Is it audible now? Is it visible? PPT is visible. Please, can anyone?
Yes,
Anyone?
madam.
Yes, madam. The before slide, it was audible.
Yes, madam. It was audible.
Fine, thank you. Just a minute.
First slide. You are not able to.
Slide show नहीं.
एक बार sharing stop.
Okay. So continuing with it, this was all about probability. When you want a normal probability, definitely you have to increase the number of samples in your research. Okay. The second thing, that is importance of probability. Why this probability is helpful in research. The first one here, you can see the first one. The probability may be from 0 to 1. As I have given you the example when we are talking about natural phenomena, I have given you example of sun. So in that case, there is no possibility that sun can rise from the west. So we can consider that impossible probability, right? So probability always lies between 0 to 1. So how it is important in research, the first thing you can see here, it helps in classical decision making and draws procedure of estimation and testing. In first lecture itself, Pusar has explained very well, that is about estimation and testing. How probability is helping for estimation? Definitely, if you are having a population of 1,000 people, you cannot do research on 1,000 people. In that case also, you have to take 200, 300 or 100 samples as per your feasibility. Okay, so for estimating samples also, what you need, you have to use the probability. Estimation we are doing in normal routine life also. For example, if you are going to the college or you are going to somewhere and you are stuck into the traffic, what you are doing? If you are watching one truck is there, one bus is there, but you are estimating, yes, in this gap I can go, and you can come back from that traffic also with your own estimation. Okay, so estimation is nothing but your assumptions, what you are taking. With the help of that, you are finding out the probability. And second thing, that is testing. Whenever in research we are talking about testing, that is related to hypothesis. Okay, hypothesis. What is the hypothesis? Hypothesis, that is the statement which can be tested. So at the end, after research, if you want to test your hypothesis, first of all, you have to give the probability. Yes, my treatment will be effective after giving this intervention. So for proving that, probability also may helpful. The second importance here, you can see this is useful for making predictions. Okay, definitely, it's not only related to medical field or any other field. Probability, that is correlated with each and every, even daily life also, the probability that is correlated. So how it helpful for prediction? In medical, if you are there for the treatment, you can predict, yes, this treatment will be effective. If you are any weather department, you are working in weather department, yes, you can predict about weather, whether rain will come or not. Rain forecasting can become with the help of this probability. Third, if you are working in a business area, definitely you can predict about the risk of any budget, risk of any financial plan. Okay, so in any area you are working, it helps for prediction. The third thing you can see here, that is indispensable tool for all studies which involves uncertainty. When you can use probability where you are not sure about your data. Here the word you can see uncertainty. Uncertainty, that means you are not sure about participant, where you are not sure about your samples. For example, a researcher wants to do a research study on novice nurses, decision-making power in emergency situation. Okay, the nurses who are new, okay, already they have completed that UG course, they are not having experience. How they are taking a decision in emergency situation in ICU? If you are doing research on this, so there are so many factors are there. You are not having that actual data. You are not having that actual assumption that whether they will be able to take the decisions or not, and you are also not sure that which type of patients will be there in ICU. You are uncertain about all the things. So in that case also, you can have this probability and you can predict that, and after the result you can prove that. The fourth thing, that is identify likelihood, chance of risk involved in occurrence of specific disease. Definitely, as we are from the medical field, so here how probability is helping you for the primary and secondary prevention. As we all know, primary prevention, that is for the preventive aspect, and secondary prevention, that is for early detection. So suppose if you are identifying that this many people are having diabetes, this many people are having hypertension. So in that case, you can do the early detection and you can use the preventive measure also. So for that also, probability may be helpful. So these are the importance of probability. Next, the main point, that is normal distribution curve. Whenever we are talking about this normal distribution, definitely the one thing will be come in your mind, that is normal distribution curve. Okay, if you are a teacher, might be you have learned in your statistic about this normal distribution, some bell-shaped. I think this image everyone will be reminded whenever we are reading about this normal distribution curve. Okay, so we are going to have a detailed session on this normal distribution curve, how the normal distribution curve is formed, what are the values are there, that we are going to discuss. Okay, so first of all, the history of normal distribution curve. Here you can see the first, it was discovered by English mathematician De Moivre in 1733. Okay, but it was rediscovered by Carl Gauss in 1809. Maybe everyone has heard this name, that is Carl Gauss. Okay, because of this name only, they have given the another name for this normal distribution curve, that is Gaussian distribution. Okay, with the name of this mathematician. Second name of this normal distribution curve is probability distribution. As we have discussed in first and second slide itself, the meaning of probability. So here the probability principle is also followed in making normal distribution. So we can consider this as a probability distribution. And third one, that is we can also consider as a bell curve. Why they have given this name bell curve? Because the shape of curve that is of bell shape. So this the name they have given, that is a bell curve. Okay, so might be everyone has heard this name Gaussian distribution, or it can be considered as probability distribution, or it can be considered as a bell curve. So this image will comes in your mind whenever we are talking about this normal distribution curve. So we'll discuss what are the characteristics, how this normal distribution has been made up, that we are going to discuss today. So if we see the characteristics of this normal distribution curve, the main two parameters are here in this bell shape. Okay, the first one here you can see this is mean, and second one you can see here that is standard deviation. Definitely we are from medical field, so if I am talking about infection control or biomedical waste management, within a fraction of seconds something will come in your mind, right? But if I am talking about standard deviation or variance or anything, you have to put some pressure in your mind, right? So I'm just revising this statistic, as we have talked about mean, median, and mode. So I'm just refreshing your mind what is mean, median, and mode. So mean, here in first image you can see. What do you mean by mean? Okay, here suppose if you are having this 11 samples. So you are calculating 11 samples divided by 11. That is number of frequency. And you are finding out the value. That value we can consider as an average value. That average value can be considered as a mean. Okay, so I hope this is clear to you. You are calculating this and dividing the number of frequency. That's what we can consider as a mean from your samples. The second image you can see here, that is median. What do you mean by median? You are ordering your data in a descending form, and the middleest value what we can consider as a median. So for example, here 11 samples are here. So 5 will be left side, 5 will be right side, and the middle value what we can consider as a median. Suppose in middle, if you are getting a 2 values, then sum of 2 values divided by 2. Whatever value you are getting, that's what we can consider as a median. And what do you mean by mode? Mode, that is the most repeated value. Okay, mostly repeated value, that's what we can consider as a mode. So why I have explained this three? Because it's having a most important aspect in this normal curve. Here you can see this is the normal bell-shaped curve. The mean, median, and mode. These three things will be same. Okay. That is the meaning of this normal curving, mean, median, and mode. If you are having a normal distribution of data, if your samples data are distributed equally, then definitely from your sample, mean, median, and mode, these three things will be same. Okay, this is the meaning of this one. Second parameter, if we talk about, that is standard deviation. Now, since morning you are listening this word standard deviation, standard deviation. But what is standard deviation in terms of this normal distribution? Here you can see the first and definition, how much data scatter around the mean value. That's what we can consider as a standard value, standardization, standard deviation. Okay, this is the mean. Here you can see this line. This is what we can consider as a mean. The data which are fall around this mean here, that gap we can consider as a standard deviation. If we understand with the example standard deviation, suppose one family is here. Okay, total 6 members are here. You have calculated the height of each family members, and you got the average, that is 155 centimeter. Okay, average, that means mean. Already I have explained you what is mean. You calculated mean and you have found that 155 centimeter mean is there. Okay, now the first person's height, suppose that is 173. So what is 173 minus 155? That is 18 centimeter. The second person's height, that is 147 something. 147 minus 155. So it is 8 centimeter. Okay. Here this person is having 140 centimeter. So you are doing minus from 155 to 140, that is 15 centimeter. So what it is considered? It is considered as a individual mean difference. This 18 centimeter, 8 centimeter, 15 centimeter. This is what we can consider as an individual mean difference. But researcher is not interested in individual mean difference. What researcher is doing? He or she is doing all this value, taking this all value, and again doing the average, again finding out the average value. That average value we can consider as a standard deviation. Okay, so I hope this concept that is clear to you. What do you mean by standard deviation? Standard deviation, that means all the varies data which are nearer to your mean. You are finding out the average value of that. That's what we can consider as a standard deviation. So here from the calculation, they have found that 12.06 centimeter standard deviation is there. How you can have an explanation of this 12.06? Suppose your standard deviation is high. Here this curve, you can see standard deviation is high. Your standard deviation high, that means your values are more far away from your mean. That means whatever data you have collected, that is not sufficient, that is not real. Okay, your standard deviation must be ideal as a bell shape. If it is too much broad, if it is too much narrow, that means your values are different. Okay, so I hope these two areas are clear to you. So normal distributions are having two parameters, that is specifically mean, and second one, that is standard deviation. Okay. Next one, that is characteristics of this normal distribution curve. The first characteristics, that is symmetry and bell shape. So everyone knows symmetry. What do you mean by symmetry? So symmetry, that means 50%. Here you have seen this mean. This is the mean value. That means suppose if you have taken 100 sample, then 50% samples value will fall here and 50% values will fall here, positive and negative side. That's what we can consider as a symmetrical. Okay, equal shape will be there around the mean. That's what we can consider as a symmetrical. And definitely it is a bell shape. So whenever we are collecting the data for your research, what we are doing, we are plotting the graph. Okay, so basically we are plotting in a, for example, यहाँ पे histograph they have prepared. So for example, in between 10 to 20, this many people are here. Between 20 to 30, this many people are here. Then they are attaching this line and making the curve. This curve is known as normal distribution, or it curve can be considered as a bell curve. Okay, so I hope these two characteristics are clear to you. First one, that is it's in a symmetrical form. That means 50% data will be left side and 50% data will be on the right side. And it will be always in a bell shape. Okay, if this shape is getting disturbed, that means your data are not distributed properly. The second one, that is empirical rule. Okay, normal distribution always have empirical rule. Empirical rule, here you have to remember these three things. Okay, these three numbers you have to remember. That is first one, that is 68, 95 and 99.7 rule. How these three numbers can be defined here? Just again keep this bell curve in your mind. Just forget about this all thing. Just here you know that this is the line what we can consider as a mean. Here mean, median and mode, these three things will be equal. Okay, now you here just plot a 0. Here you take a number 1, 2, 3. Here -1, -2, -3. What is the meaning of this line? Here the one number we can consider. If your values are falling here, we can say that my values are having positively one standard deviation away from me. Okay, this 1, 2, 3, and these are considered as a standard deviation. As I have discussed in definition also, the values which are falling nearer to mean can be considered, that gap what we can consider as a standard deviation. So here we can consider this is the first standard deviation. This is the second standard deviation. This is third deviation. Here it is also, but it is in a minus form. That means it is going in a negative way. Okay. So if your values are falling here, you can say my values are one standard deviation away from mean, two standard deviation away from mean. Okay. Here also you can say 3 standard deviation away from mean, but negatively. Okay. This word you have to use. So I hope this is clear to you. Next one, moving to empirical rule, these three values you have to remember. What is the first value? That is 68.2. What do you mean by this 68.2 values? That means suppose if you have collected 100% of data, 100 samples suppose you have taken. So the data of 68 samples must be covered between this -1 to 1. Okay, here -1 standard deviation and 1 standard deviation. All data must be here. The second standard deviation, that is 95.4. This value, that means around 100, 95% samples must fall between this -2 to 2 standard deviation data. And 99.7, that means the 99 samples value must be fall between this -3 to 3 standard deviation data. Here sigma they have written. Sigma, that is the standard deviation only. Mu, that we here you can see this is mu. Mu, that is the population mean, not sample mean. Whatever population you have taken, you are finding out the average of that, what we can consider as a mu. Sigma stands for standard deviation. Okay, so I hope this is clear to you how you have to define this empirical rule, that is 65, 68, 95 and 99. 68, that means from 1 to 1, -1 to +1 standard deviation, all values will be here. You have taken heights of 100 students. 68 students height will be in this area. Okay. 95 students height will be in this area from -2 to +2. And all the samples age will be in this area, not outside of this bell curve. Okay, this is the meaning of this empirical rule. So I hope this is clear to you. And third characteristics of this normal distribution, that is standardization and Z-score. Now, what do you mean by standardization? Standardization, that means suppose if you are having not a normal distributed data, with the use of trimming or with the use of formulas, you are making in a normal distribution. That's what we can consider as a standardization. Okay, so few formulas are also there, or you can trim the data which are not correlated with your main data set, just you are removing that samples. That type of trimming can also be done, and you are following the standardization. Okay. And second thing, that is Z-score. What do you mean by Z-score? Here again, this one here you can see Z. Okay, this is standard deviation. Standard deviation is here 1 sigma, 2 sigma, 3 sigma minus. This is standard deviation. Now what is Z? Z stands for the values of standard deviation. Okay, Z, that is the standard value. How we are having this chi-square table, how we are having this t-test table. In the same way, we are having this Z-test table also. Okay, with this table value, you can prove your hypothesis. You can prove your assumption at the end of your research. Okay, so Z, suppose Z you have found in your research study and you have found that it is 1.3. So 1.3 somewhere it will come here. So you can use the table, you can find it out that at 1.3 which value is there, whether I can accept my hypothesis or not. So for values of this standard deviation, we are having this Z. Okay, so I hope this is clear to you. So if we talk about the characteristics of normal distribution, these 4-5 things you have to remember about mean, median, and mode. What it is. The second thing we have discussed about this standard deviation. What do you mean by standard deviation? Second thing we have discussed, that is empirical rule. Which type of value, which value falls between 1 to 1, 2 to 2. That empirical rule you have to remember. And third thing, that is standardization and Z-scores. Okay, so this was all about the characteristics of normal distribution. So whenever you are learning about this normal distribution, always or else when you are doing this critical analysis of any articles or anything, the two things will always come, that is confidence, CI, that is your confidence interval, and second one, that is at p-value. Okay, so might be you have heard this word. What do you mean by confidence interval? The two terms are here, confidence and interval. Now, what do you mean by interval? Interval, that means range. Okay. Range, that means in range always you are having the high value and low value. Okay. So you are giving a range confidently that your values will come here. That's what we can consider as a confidence interval. If we learn with the example, for example, few basketball players of Gujarat. These are the basketball players of Gujarat. Suppose you want to assess the height of these all players. Is it possible to take all the samples? Definitely no. So you are taking few samples, one group you are taking and you are assessing the height. Okay, you got this much mean. Okay, first time. For example, here you can see second time from the same population. Here basketball players only, but not with this sample of group. Again, other sample you have taken and you have done the research. Suppose you have got mean here. Okay. third time you are doing research, suppose you are giving you are getting your mean here. That means it is not possible that every time you are doing research and you are getting the same mean. Is it possible? No. Here you are getting this mean. Is it possible that every time I will get my mean here only? No. So because that you are giving one range. For example, you have given range, it is 19, that is lower limit, upper limit, that is 30. So you are giving confidence that anytime you will do research from this population, your mean you will get that will between 19 to 30. Confidently you are telling with that range. That's what we can consider as a confidence interval. Okay, so I hope this concept is clear to you. Confidence interval always focus on your population. They are giving some surety about your population, right? So this is the range of values you expect your estimate to fall between if you redo your test within a certain level of confidence, right? The same thing I have explained with this example. So I hope the CI that is clear to you. And second thing, that is p-value. P-value is always used in all type of research. So what do you mean by p-value? P-value indicates the probability. P stands for probability that one outcome, that an outcome this extreme could happen if the null hypothesis were true. Okay, P-value always focus on null hypothesis. Now everyone know null hypothesis. What do you mean by null hypothesis? Where you are believing that your treatment will not be effective. Okay, suppose it comes effective. What do you mean by P-value? P-value, that means you are giving a percentage that this many percentage are there. It may happen. This effectiveness may happen because of any other extra or external factor. That surety you are giving, that's what we can consider as a p-value. For example, here given 0.05. In medical area, always we are using this p-value, that is 0.05. What do you mean by 0.05 p-value? That means 5%, there are 5% chances that my result can be because of any other factor rather than my treatment. That's what we can consider as a p-value. But 95% I am sure. For example, you have done one research, that is effectiveness of foot reflexology on stress. So finally, if you are taking this value of 0.05, that means 5% only you are having error, that whether this stress was reduced because of foot reflexology or not. Only 5% error you are accepting, but 95% confidently you are telling no, this error has happened because of any other factor, but other than that 95% my data are true and the stress has been reduced just because of foot reflexology, right? So whenever you are criticizing, whenever you are doing this systematic review, critical analysis, you will find this type of tables. In that also this p-value will be there. So you must understand about this p-value and how it is correlated with the research, right? So again, one more example, if p is equal to 0.10, that means here confidence interval, that is 90%. That means 10% you are not sure that because of foot reflexology it may happen or not. But 90% you are giving surety that because of my intervention this thing happened. Okay, so what is the simple meaning between this p-value and confidence interval? P-value always tells something about your sample, not about population. And confidence interval, that gives surety about your population. Okay, so that is the basic difference between this confidence interval and p-value. Okay, so whenever you are doing this systematic reviews or any RCT studies, you may see this type of graph also. This graph is also correlated with normal distribution. As we have seen this normal distribution, here the middle line, what we can consider is a mean. The same line here, you can see this is the no effect line. So confidence interval, I have already explained you. Suppose with the formula in your research, you have found confidence interval that falls, if it falls on this no effect line, that means your intervention is not effective. Okay, if it falls here or if it falls here, we can accept the hypothesis what we have prepared, null hypothesis in our research. Okay, so for interpreting this data, this basic information that is needed. So we have discussed about confidence interval, p-value, and significance of this confidence interval on this plotting. So this was all about the normal thing. This is all about the normal data. Now, if we move on to the abnormal data, if abnormal distribution are there, what we can consider as. Okay, so basically two things are here. You can see skewness and kurtosis. So what do we mean by skewness and what do we mean by kurtosis, that we are going to discuss. Skewness and kurtosis are statistical measure used to describe the shape and characteristics of distribution in statistics. Okay, we are mainly focusing on shape here in skewness also and kurtosis also. The shape will not be in a bell shape. Okay? Normal, if you are having a normal distribution, there will be a bell shape. But if you are having an abnormal distribution, it will not follow the shape. So what do you mean by skewness? Skewness is a measure of symmetry in which can be positive or negative. Okay, we'll discuss in detail one by one. First one, that is skewness. Okay, what do you mean by skewness? Here in picture, this picture you can see here, this is the bell curve. Okay, the curve is saying let's compromise and we'll go normally. But what this two part is doing, this part is saying no, I will take more data. This part is telling no, I will take more data. And because of that, this line will follow like this. Okay, positively if we going here, it will be narrow, it will be wide. If negatively it goes, then like here it will be narrow and it will be wide. Okay, so this type of distributions if you are getting in your curve, that's what we can consider as a skewness, right? So if we see in the detail here, you can see if one tail is longer than another, the distribution is skewed. Here you can see this is the normal probability curve. What do you mean by tail? Tail is the end of this curve, what we can consider as a tail. Okay, so when one tail is wider than another, in that distribution we can consider as a skewness, right? So these distributions are sometimes also called asymmetrical distribution. The another name of it, that is asymmetrical distribution. The normal curve, already we have discussed that characteristics of normal curve, that is symmetric distribution will be there. That means 50% data will be here and 50% data will be here. But if skewness happen, what will happen? Only 20% data will be here and other 80% will be on right side or other 80% will be on left side. So that type of distribution, what we can consider as a asymmetrical distribution. Okay, so I hope this is clear to you. And here we are having two types, positive and negative skewness, or it can be considered as a right skewed or left skewed. We are going to discuss in detail. First one you can see here, that is positive skewness. What do you mean by positive skewness? In a distribution that is positively skewed. Okay, when positive and negative things come, again you just remember this bell-shaped curve. Here these values, what we can consider as a positive value. Here we considered as a negative value. So all your datas, you are getting 100 samples, you are getting all datas are on this side. That what we can consider as a positive skewness. Your shape will be like here, like this. That what we can consider as a positive. If your all data that falls here on negative side, what we can consider as a negative skewness. Okay, so first one, positive skewness, positively skewed, that means the values are more concentrated towards the right side, and left side it will be spread. That's what we can consider as a positive skewness. Here this thing you have to remember, whenever you are having this positive skewness in normal distribution curve, suppose this curve was like this, then mean could be here. Okay, but here you are having this positive skewness, your mean is falling here. That means your mean will be more than median and your median will be more than mode. Okay, so this thing you have to remember in positive skewness. So if we give the example of positive skewness, for example, your exam is there and toughest paper is there. The paper is too much tough. Definitely no one will get high marks. Okay, everyone will get this average marks. So in that case, you may have this positive distribution. The another example you can see here, that is distribution of movie tickets. Definitely everyone wants entertainment. No one is like, I will not go for entertainment. But suppose movies were normal, but one blockbuster movie came. What will happen? Suddenly all tickets will be sold. Okay, so that what we can consider as a positive distribution. The third one, if you are doing research on points scored per game. Okay, you are doing research on children who are playing regular games and how much points they are getting. So definitely they are regularly playing. That means all players will be have that first stage, second stage clear, third stage clear, fourth stage clear. Only few players will be there who can reach up to 20 or 300 step of that particular game, right? So in that case also you may get this positive type of distribution. So I hope this is clear to you, that what we can consider as a positive skewness. Now, what do you mean by negative skewness? In a negatively skewed distribution, the data points are more concentrated toward the right-hand side of the distribution. This makes the mean, median, and mode bend towards the right. Hence, these values are always negative. Okay, here you can see all values will be here. Here also mean will be here, but here minus value. Okay, left side all the datas are here. So we can consider mean will be less comparatively to median and mode. Okay, this thing you have to remember. That's what we can consider as a negative skewness. What are the example of negative skewness? The first one, that is distribution of age of death. Suppose if you are calculating the age of persons, so definitely around the age 70, 80, you will get more death. On children, you will get less death. Okay, so in that case, you can have this type of negative. If you are doing research on distribution of long jump length, suppose you participants are there who are participated in long jump. So definitely they have participated. That means they are capable to jump around 7 to 8 centimeters, right? Only few participants will be there who can jump only 3 centimeter or 4 centimeter, right? So in that case also you can get this type of negative skewness. For example, you are having the easiest exam, easiest paper is there. What will happen? Everyone will get a good marks. Everyone will get average marks. No one will be failed, right? Because the paper is too much easy. So this example, in this case also, you may get this type of negative skewness. Okay, so I hope these two areas are clear to you. That is positive skewness and negative skewness. The thing you have to remember, this is the normal one, bell-shaped. Positive skewness where the mean that will be more, and negative skewness in that mean will be very much less comparatively to mode and median. Okay, so I hope this is clear to you. So if you are not having a normal distribution, and if you find it out, if you want to find it out, how much skewness is present in my research data. So for that, I'm not going into the detail, but this coefficient, Carl Pearson's coefficient of skewness, Bowley coefficient of skewness, and Kelly's coefficient skewness is there. With the use of this formula, you can find it out that how much skewness is there in your research data. So this is the interpretation of this data. Here you can see if it is 0.5 to 0.5, here again you come here. Here it is 0, 1, 2, 3. That means minus 0.5 is here, plus 0.5 is here. If you are getting value between this, we can consider as it is normal. Okay. If it is come between minus 1 to 1, this skewness can be considered as a moderately skewed. So that means it can be okay for getting a result of your research. But if it is more than 1, more than minus 1, if you are getting your skewness, that means your datas are not correct. Here you have to correct your result. Okay, so I hope about this skewness concept that is clear to you. What do you mean by kurtosis? In kurtosis, we are assessing the tailedness. Okay, how tall your bell-shaped curve is, that you are assessing what we can consider as a kurtosis, right? So here in kurtosis, here you can see you are having a 3 type of kurtosis are there. First one, that is lactokurtic distribution. Second one, that is mesokurtic distribution, and third one, that is platykurtic distribution. So how you can differentiate these 3? The first we'll discuss one by one. First one, that is platykurtic distribution. So what do you mean by platykurtic distribution? The platy in platykurtosis comes from Greek word platus. Platus, that means flat. Okay, here this is the normal bell shape, but here you can see this graph is getting flat here. The peak of the graph that is getting a flat here, that type of distribution what we can consider as a platykurtic. Why this type of values are happening like this? Because here the outliers are very much less. Okay, what do you mean by now outliers? Outliers, that means the values which are not fitted into the normal data set. For example, I was assessing the average weight of any class student. So I found that all students' weight were between this area only. I have not found below 40. I have not found more than 80. So in that case, I can have this type of distribution. That's what we can consider as a platykurtic data. Okay, so I hope this is clear to you. So here the same example, other example they have given. A sociologist is studying the social media use of students at a small high school. There are 400 students at the school ranging in age from 14 to 18 years old. Here you can see they have taken this school and they are assessing the social media use of children, but they have found that below 14 no one was there, more than 18 no one was there. So in that case you can have this type of curve, what we can consider as a platycotic, where the outliers here, whatever values will come, outliers, they are more far away from your median, what we can consider as a outliers. So here the number of outliers that will be very much in less amount, that's why we can consider as a platycotic. Okay. The second one, that is mesocotic. What do you mean by mesocotic distribution? Mesocotic distribution, that is the medium-tailed distribution. So outliers are neither highly frequent nor highly infrequent. In short, we can consider this data as a normal distribution data. Okay, the difference will be there, but in points, only 0.5 difference will be there. So that distribution, what we can consider as a mesocotic distribution. For example, if you are taking a normal average birth weight of baby, suppose you have found 3, that is the mean value what you have found. So definitely that is true. Every newborn baby will be have that weight around 3 only. Okay, it will not go up to the 7 or 8. So definitely you are going to have this bell-shaped curve at the end of your result. So that data what considered as a mesocotic data. Okay. Lactic data. What do you mean by lactic distribution? That is fat-tailed, meaning that a lot of outliers. Here you can see more outliers. As in platycotic, we have seen the outliers were very much rare. The opposite of that, in lactocotic, you are having a more outliers are here. The more values will be there which are far away from your mean. That what we can consider as an outlier. So if you are having these outliers more, definitely here you can say this is the fat line you can get here. Okay, and here it will become a too much narrow and it will be picked. So that's what we can consider as a lactocotic. Okay, so lactocotic distribution is fat tail. That means the tail, here you can see the more gap will be there, more outliers will be there. Lactocotic distributions are more cototic than a normal distribution, and lacto, that means narrow. Okay, your curve what you will get at the end of your result, that will be in a narrowed form. So for example, here they have given 4 astronomers who are doing research that distance between Earth and any one star. Okay, so 100 times they have done that and they have plotted this graph. So in that also they have found that all values, all height they have found. Here also, here also, here also, because they were not sure about this. So that data what we can consider as a lactocotic. Okay, so I hope this is clear to you. So basically in kurtosis, we are having these 3 types. That is the lactocotic, mesocotic and platycotic. But mesocotic we can consider as a normal bell-shaped only, normal distribution also. Platycotic, what we can consider as a negative kurtosis. That means the tail that will be very much thin. And lactocotic, where your tails are here, that will be very much fat. That will be very much thick. That what we can consider as a lactocotic. So I hope this is clear to you. So kurtosis, this is the formula of finding the kurtosis as we have discussed in skewness also. Here also you can find it at your kurtosis value. It always denoted by beta. Okay, so a normal value of this kurtosis is 3. That means if you are having 3, that is normal kurtosis. If it is more than 3, what we can consider as a lactocotic. If it is less than 3, that is what we can consider as a platycotic. Okay, so I hope this is clear to you. We have discussed about normal distribution also, what are the characteristics, and abnormal also, that is about skewness and kurtosis. Now the last thing, that is analysis, how you have to apply in case of normal and abnormal distributed data. Here also researcher plays a major role of selecting this statistical test. So basically, as we all know, we are having 2 tests, parametric test and non-parametric test. So where we are using parametric test when you are having a normal distribution, when you can use parametric test when you are having this normal distribution curve, then only you can use this parametric test. When you are having an experimental design where you have used control group, where you have used randomization, manipulation, all the characteristics if you have followed, and finally if you got bell-shaped curve, then only you can apply this parametric test. Okay, if your data, if you have prepared plotted a graph, if it is it will not all use of parametric test. Okay, so here I have added some parametric and non-parametric tests. So before going to this, here first two you can see here, first one for checking normal distribution and second one for homogeneity. Okay, so always whenever you are having a normal distribution, when you will have your normal distribution, whenever you are following a homogeneity. Homogeneity, that means whatever sample you have taken in your research, that must have a same characteristics. Okay, so for checking of that, this tests are available. Okay, so if you are going to follow a parametric test, then before that you have to check this normal distribution and homogeneity. If you are getting a good result in this one, then only you have to go for parametric test. Then we can say that your result is reliable. Okay, otherwise it is not reliable. So for checking this normal distribution, these two tests you can see here. First one, that is Kolmogorov-Smirnov test, and second one, that is Shapiro-Wilk test. Okay, this test usually describe the difference between two values, whether these values are correlated with mean or not. Okay, finally they are giving the p value. If p value is greater than, we can consider our data are having normal distribution. If not, then we can consider it as an abnormal distribution. The second thing you have to assess, that is homogeneity. For checking the homogeneity, Levin's test is there. Levin's test basically follows a variance. It find out the variance. The variance must be difference. What do you mean by variance? Variance is nothing but the square of standard deviation, what we can consider as a variance. Okay, so Levin's test, they are assessing with the formula variance. The variance must be different. If it is coming same, that means your data are heterogeneous. If it is different, that means homogeneity, that is maintaining. So if you are getting this two normal data, then only you can go for parametric test. Otherwise, you have to go for non-parametric test. Okay, so we'll discuss one by one. For example, first one, comparing two independent group. Suppose if you are doing a research where you are having a two group, first group you are giving a yoga, second group you are giving a foot reflexology, right? Suppose, so if you are having a normal distribution data, if you have done the RCT, which test you will follow? That is the unpaired t test. Okay, if you are having a normal data. But suppose if your data are not normally distributed, what you will do? You can use this test. Okay, the first one, that is Mann-Whitney U test, and second one, that is Welk's t test. Mann-Whitney U test, that suppose unpaired t test, that usually assess the mean. Here Mann-Whitney U test, that follows a rank. Okay, rank difference of both group it will give, and we can finalize that which one is more effective. Welk t test, where you can use, suppose you are having a two group, but the number of samples are different in both group. In one group you are having 30 and another group you are having 25. In that case, you can go for this Welk's t test. Okay. The second one, here you can see, for comparing more than two independent group. That means you are not now have only two group, you are having four group. In four groups, you are giving different type of interventions. So in that case, normally if your data are normally distributed, what we are using? That is ANOVA, right? Analysis of variance, if it is normally distributed. But suppose you have made a curve and you are not getting a normal distribution, you have assessed this two also and it is also negative. So in that case, you can go for this non-parametric test. So here you can see first one, Kruskal-Wallis test, and second one, that is Dune's test. Kruskal-Wallis test basically follows median. It will find it out the median of each group and how it is differ, which one is effective. That result you may get from Kruskal-Wallis test. The second one, that is Dune's test. Dune's test, that what we can consider as a post hoc analysis. Whenever you will read this statistical part, what do you mean by post hoc analysis? Post hoc analysis, that means you are going into too much detail. Okay, here Kruskal only giving the answer that this group is more effective to this. But post hoc analysis, that means all the difference between that four group, what are the factors that may have affected that group, all detailed descriptions that you may get in post hoc analysis. Okay, so that is what we can consider as a Dune's test. Next one, that is comparing two related paired samples. This was all about unpaired. This unpaired, that means you are having two different groups. Now, if you are doing research on same group, suppose you have taken pre-test and post-test and you want to do the analysis. So if you are having a paired samples, usually normal distribution data are there, what we are using pair t-test. Okay, everyone knows. But suppose if you are not having normal distribution, then you have to go for test that is Wilcoxon signed rank test, or you can go for sign test. Okay, Wilcoxon signed rank test always, the name itself says that it will find it out the rank of pre-test and post-test, and it will justify your hypothesis. The same thing, sign test can also be as an alternative we can use as a instead of paired t-test. Next one, that is comparing more than two related pair samples. That means paired sample. That means only one group is there, but you have taken data more than 2 times. For example, you have assessed pain before operation, during operation, after operation, after 4 hourly, after 6 hourly, and you want to correlate that. Usually, if your data are normally distributed, what we will use, that is repeated measure of ANOVA. Okay, that can be used if you are having this normal distribution. But suppose if you are not having that normal distribution, you can go for this Friedman test, or you can go for this Durbin test. Durbin test, that is again a post hoc test. Friedman test, as I have explained earlier, before, during, after, which pain was more reduced with your intervention, that result you can get from Friedman. But post hoc Durbin test, that means you can get in detail description, which pain was more, which pain was moderate, why it was moderate, how it is correlated with third group, second group, first group. All the details you can get with this post hoc analysis of Durbin test. Okay. Next one, that is correlational between two variables. Okay. When you are doing study, correlational study, for example, smoking and lung cancer, very well known example, right? So in that case, if you are doing a research, you want to find it out correlation, and if your data are normally distributed, what we are using, Carl Pearson. Okay, everyone knows data are normally distributed, then we are going for Carl Pearson. But if you are not having normal distribution, we have to go for Spearman's rank correlation and Candles-Tau. These two tests can be used. Spearman rank correlation usually gives strength as well as direction. How this smoking is correlated with lung cancer and which direction it will go, positive or negative. Both things will be given from this test. Candles only give the strength of that, whether it is correlated with one another or not. No any direction will be there. So these two tests can also be used when you are having this non-normal data. And last one, that is testing relationship between categorical variable, where we are following association and all that things. For finding out the association, as we all know, we are using chi-square. So no any alternative for chi-square only you can use. But if you are having a smaller sample size below 30, you can go for this Fisher's exact test. Okay, so these are the few tests. Here only you have to, being a researcher, you have to decide that which type of test you will use, how you will use, when you will use. If you are taking a wrong test here, wrong statistical analysis here, definitely your result is going to affect it. Okay, so this was all about parametric and non-parametric test. And finally, what are the factors? So definitely we understood that if we want to have a good quality of research, good quality of statistic, we must have a normal distributed data. Then only we can have a good quality of research, right? So for getting that data, which factors are affecting, in which factors you can focus more. So here 6 factors are there. First one, that is sampling method. So being a researcher, as we all know, we are having 2 type of method, probability and non-probability sampling method. So if you want to have this normal distribution, try to use probability. As we all know, simple random sampling, stratified random sampling. If you are using this probability sampling, there will be more chances to have this normal distribution. The second thing, sample size. A lecture has been done morning only. Sample size matters a lot. If you are having a less number size, definitely your result will affect. You are having a more abnormal large size, that may also affect your result. Okay, so as per your population, you have to decide your sample size. That also matter. But sample size should not be too small. Okay, it should be in a large size, right? Third one, that is data collection technique. Always try to find it out the actual data. Okay, if you are doing any physiological parameter, if you are assessing, try to get the actual data, or with the standardization test you try to collect the data, and all the data must be in a quantitative form. If you are using the qualitative, definitely there will be a chances of error will be more. The fourth thing, that is handling outliers and skewness. As we have discussed, outliers, that means few datas will be out of your data set. Okay, they will be more far away from your mean. That type of outliers must be trimmed, that must be excluded from your research. Then your research can be good. Okay, so next one, that is population characteristics. As we have discussed, homogeneity. Okay, the homogeneity is nothing but the characteristics of all your sample must be matched with one another. If it is matching, definitely you may get this normal distribution, right? So this thing also you have to keep in mind. And last one, that is experimental design. So instead of choosing descriptive design or survey design, always try to use experimental design. You do the RCT, definitely the normal distribution you may get. So these are the factors that may also affect your normal distribution. Okay, so this was all about my topic of normal distribution. So we have discussed, I'm just concluding my topic. We have discussed about the normal bell curve. What is it? The mean, standard deviation, empirical rule, standardization, what is CIP value, how we can differentiate, that we have discussed. And abnormal part, we have discussed about skewness and kurtosis with example what it is. Okay. And lastly, if you are having a normal data, which type of statistical test you can use, and if you are having a non-normal data, which type of test you can use, that we have discussed. So it was all about my topic. If anyone is having any doubt. Okay, so this was all about my lecture. I'm handing over to Priya. Thank you, everyone.
Thank you so much, ma'am, for delivering such an insightful and engaging session on normal distribution of samples. Your clear explanations and expert guidance have helped us deepen our understanding of this important statistical concept. We sincerely appreciate the time and effort you have put into making this session informative. So now, next, moving on to our next session. So I'm honored to welcome Dr. Suresh V. So to lead today's session on meta-analysis and forest plot interpretation. His expertise will provide valuable insights into analyzing and interpreting data effectively. So search credentials. Dr. Suresh B. Sir, HOD and Professor in the Department of Mental Health at Sumandeep Nursing College, has expertise in psychiatric nursing, systematic reviews, and meta-analysis, and is a core staff member of the JPIC entity. With over 65 publications in renowned journals, Sir is recognized for his research in psychopharmacology, metabolic disorders, and psychosomatic conditions, and has received the Best Researcher Award in 2017. A peer reviewer for multiple journals, Sir is a member of the UNESCO Chair in Bioethics Haifa Steering Committee and a lifetime member of the ISPN. So now we are going to begin with the session. Over to you, sir.
I hope my slides are visible. Is it visible? My slides are visible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you so much, Priya, for giving me the detailed introduction about my credentials. And first of all, I thank organizing chairperson, Dr. Anita Pragasam, Principal Ma'am, for giving me this opportunity to speak about my topic. So today's assigned topic for me is meta-analysis and forest flood interpretations. Um, Before going to talk about meta-analysis, it's so important and high-level research work. Before going to talk about the meta-analysis, I would like to brief out some fundamentals to understand to have a better understanding about meta-analysis. Let us have a basic idea about research design. Therefore, you can have a better understanding. The research design it's classified into two. One is a primary research design and the other one is a secondary research design. Okay, I would like to differentiate what does it mean by primary research design, where the researcher are working on ground, they are collecting the data, they do analysis, coming to the conclusion. It's all about primary research, which means the person or the individual is performing the research. It's all about primary research. Coming to certain examples which I have shown you, the case series, survey, if you talk about cross-sectional study, case control study, cohort study, or everything are the individual researcher going into the field, collecting the data, analyzing the data, and they are publishing. This is all about the primary research work. If you talk about the secondary research, where the researcher is not performing the research. For an example, systematic review and meta-analysis both are comes under the category of secondary research, where they are not performing any research. I would like to give an explanation about systematic review. What does it mean by systematic review? And what is meant by meta-analysis? Meta-analysis is just an extension of the systematic review. Let us understand what is meant by systematic review. I have given an example. You all know schizophrenia has two types of symptoms. One is positive symptoms and another one is negative symptoms. So, after administering antipsychotic drugs, it has a better effectiveness on the positive symptoms. It is coming down, the patient would be behaving normally. But whereas, in spite of administering antipsychotics, negative symptoms are not managed properly. Okay, so there are certain researches going on. In Australia, there is a research they have performed. They have injected oxytocin to handle the negative symptoms of schizophrenia. They found there is some propensity in reducing the negative symptom after administration of this oxytocin. Okay, so that only one research they might have conducted. With this one research, we cannot able to come to the conclusion, and we cannot recommend somebody to prescribe the oxytocin to administer to reducing the negative symptoms in any clinical settings. We cannot able to make any protocols. We cannot make able to make any standard operating procedures to administer oxytocin to reducing the negative symptoms with the help of only one research performed, because there are a lot of bias would have happened. As in the morning session that sir has highlighted, then there are a lot of bias. There are chances of getting bias in a single study. It may be the person might have manipulated the result. Is one of the problems. There would be a lot of confounding variable may be affected the result. There are a lot of problems that may end up with the bias. So we cannot determine or we cannot make any SOP or protocol with a single study. So we need certain multiple study to go through. Then finally we need to come to some conclusion. This is all about systematic review. Okay, here in secondary research, what I'm trying to explain in the systematic review, I am not doing the research. For an example, I am doing the systematic review. I'm not doing the research. I'm sitting here with the help of internet and a lot of databases which is available. One second. Full screen. Clear? Yes. So, as a researcher, as a secondary researcher, I want to perform a systematic review. So, I'm not going into the field or groundwork for doing the research. I'm sitting here with the help of internet. There are a lot of databases which is available. Like the well-known databases is PubMed. Okay, it's a free of cost which is available. Apart from that, there are a lot of databases like Trip database which is available, Cinehub, EBSCOhost, Scopus. There are multiple databases which is available. They are paid version. We cannot able to know unless until if you're not subscribing, we cannot able to access any literature in the particular databases. But in case of PubMed, it's a free database we can able to access certain extent some literature can be accessed. Okay, what I supposed to do it in the systematic review with the help of these databases. My topic of interest, my problem is I want to reduce the negative symptoms of schizophrenia. So with the help of oxytocin, so I'm sitting here, I'm using the internet, I'm searching all the searching the same topic which is performed in the different area. I have told you just I have gone through some literature that I found it in Australia. Similarly, few people might have done the same work, the same oxytocin might have tried to tried on schizophrenic patient to counteract this negative symptom in Canada. Somebody might have done from Chennai, somebody might have done from Ahmedabad. There are multiple study on the same name have been published, which is accumulated in the PubMed. So as a secondary researcher, I go through all these, collect all the researches, what they have performed in the different part of the universe. So after collecting all those things, as the third lecture, we have discussed critical appraisal of an article, right? The madam has given the elaborate explanation about how to critique the literature. Critical appraisal, it's nothing but it's not about finding some fault about the particular article being published. It's all about to know the strength and weakness and the reliability of an article and also the quality of article. So I am reading all the articles. So I got nearly 4 to 5 articles. I'm reading thoroughly. After reading all this result, I come to know that really this oxytocin is reducing the negative symptoms of schizophrenia. So I understood. So I'm writing my own review stating that yes, I have followed this so and so article being published in the different area stating this oxytocin, which is effectively reducing the negative symptoms of schizophrenia. It has some chemical compound or the propensity in reducing the negative symptoms of schizophrenia. I am not doing any analysis here, just I am reviewing those articles. I am making my own draft and I am publishing. It is all about systematic review. Why I am emphasizing more on systematic review? The systematic review and meta-analysis both are same. Only it's differentiate with the only one information, that is systematic review does not have any statistical analysis. Whatever I have explained, that is systematic review. Whereas meta-analysis, we are using certain data to do the statistical analysis. I told you systematic review, just collecting the data and I am writing the description and I am publishing an article. Whereas similarly, meta-analysis, where I'm just not only collecting the reading the literature, also I am collecting the quantitative data. Sometimes the mean and mean differentiations and the standard deviation, I am collecting it. In case of certain case, odds ratios relative risk, which the data which I am going to collect in case of meta-analysis. After collecting all those data, I am putting into a software that will be yielding uh, uh, a diagrammatic representation. It is called forest plot. That's what we are going to discuss, how the forest plot displays, and what are the points to be discussed over here. What does it mean? What it trying to interpret? Those things we are going to discuss. Okay, this systematic review and meta-analysis both are the key component of practicing the evidence-based practices in better way. Sorry. Without meta-analysis, without systematic review, we cannot able to perform the evidence-based practices. Yes, systematic review and meta-analysis both are key components to practice our key components of evidence-based practices. Let us move on to the next slide. So, what is meta-analysis? If I have already explained the book picture, if you talk about, it's a statistical analysis. Yes, I have discriminated between systematic review and meta-analysis. In systematic review, we are not doing this statistical analysis, whereas in meta-analysis, we are doing the systematic or statistical analysis, which combines the result of several independent studies, is considered by the researcher. So here and a picture which indicating, excuse me, I'm using the pointer to highlight the informations. So you see these all the various study been carried out, and which is available in the internet or the database which I have narrated. So this is the study as I have given oxytocin, which is performed in Australia. This one is Canada or somewhere else also. So 4 different area they have conducted the same study. What I am doing, I am collecting all those information and I am accumulating all those information along with the data, as I told you. I am putting all those data into the statistical analysis that will be yielding the diagrammatic representation it's all about for us. I hope you understood what is meta-analysis. Okay, while planning the meta-analysis, we have to be very careful. As I discussed in the couple of slides back, so we are determining any protocols or standard operating procedures to practice in the clinical setting, which is majorly based on the randomized control trial and meta-analysis. Okay, as I told you priorly, we cannot make any decision with a single study. Therefore, we are collecting number of studies and the collective opinion we are taking from the number of studies, and we are finalizing one, protocol. Similarly, so if you are not performing the meta-analysis properly, that may lead to wrong treatment and it may lead to some complications, right? So, what are the steps need to be followed and how to be carried out the meta-analysis in the systematic way? The first one, formulate the review question. I have told you one example is oxytocin on negative symptoms of schizophrenia. Here, the problem is negative symptom formulation of research question. The problem here is negative symptoms of the schizophrenia. The treatment is oxytocin, which is compared with the regular antipsychotic drugs. You might be aware about PICO, means P denotes population or the problem, I denotes intervention, and C denotes comparison, O it means outcome. So we have to formulate the question on the basis of PICO format. Second one, specify the eligibility criteria. You have to be stringent in selecting the studies. You have to focus more on randomized control trial. If they have conducted some study without randomization, for example, normally in nursing fraternity, we perform quasi-experimental and other things. We need to be very much attentive while selecting the research literature, that we have to omit all the unnecessary data. If you focus on RCT, only you have to collect RCTs. You have to determine your own eligibility criteria. For example, if you want to conduct a meta-analysis in case of cohort study, or in terms of case control study, you have to be very particular about those eligibility criteria. You have to collect only the cohort or case control study. So that is all about the eligibility criteria. The next one, identify, select, and critically in the studies. So the most important part that was Dr. Rashmi ma'am has elaborately discussed how to critically appraising the article. So once you reading that, you found there is no quality in the work, or they have given misleading the your the research or something else, you have to omit all those things. That is all about critical appraisal. Unless until always systematic review and meta-analysis cannot be performed by a person. It need minimum 2% on the group of people. Not only the researcher has to go through the literature, also there would be some reviewers apart from the researcher. 3 or 4 reviewers has to be go through. We have to get the information, review information from them as well. Then finally we are selecting those studies for the systematic review as well as meta-analysis. There is a third point. Last one, collect appropriate data. Then we are putting into the software for making this analysis. These are all the steps need to be followed while doing systematic review and meta-analysis. Hope you understood some of an example. So, if will main topic of meta-analysis, it has two types. One is primary analysis and secondary analysis. First, we'll focus on only the primary analysis. Only one objective you are having here. You are you are moving towards that particular concept. Like then another example I would like to give you. See, I have found some of the potential effect of amla extract having to reducing the cholesterol level in the blood. Okay, so I want to. There are many synthetic drugs which is available in the market, like statin drugs, commonly prescribed by the cardiologist to control the cholesterol level. Though if the person is taking this statin, rosuvastatin, atorvastatin, it has side effects. Long term, if the person is taking for the longer period, it may leads to insulin dependency. Therefore, the person more vulnerable to develop this diabetes mellitus, those who are receiving this, statin drugs. Also, it has some side effects of myalgia in the lower extremities. This is all the common problem which is encountered by the people who are receiving these synthetic drugs. So recently, the people are trying to find out some of the alternative medicines to counteract this dyslipidemia at the cholesterol level. Therefore, nowadays the amla extract also found I have given on article over here. It is they are finding out the efficacy of amla extract in patients with the dyslipidemia. There is a randomized control trial they have performed, right? So what I'm trying to do with this single study, I cannot able to make the conclusion that amla extract really reducing the cholesterol level. So what I supposed to do? See, I have to perform a meta-analysis or the systematic review. My focus here, I'm talking about the primary analysis. My focus here only one thing: whether the amla extract reducing this cholesterol level or not, right? Only one objective. That is all about primary analysis. Answer the main research question. You just see here the flow chart. It's a primary analysis. Subsequently, I'm pulling all the data and estimating the study sizes. Means how far it is ineffective. I'm coming to the conclusion. It's all about primary analysis. The another one is a secondary analysis. We will discuss little later what does it mean by secondary analysis. First, let us understand what is mean by primary analysis. Okay, so primary analysis, once, as I told you, I am collecting the data, quantitative data from the various studies, and I can use the Microsoft Excel also to make this forest plot, the designs. Okay, there are certain software also which is available. So we can use this Microsoft Excel to plot this diagram. This is the forest plot diagram. When you're putting the data, this will be displayed. This will be, displayed in the Excel sheet. So how and what does it interpret? I would like to highlight on these points. See, these all the right hand side. These are the name of the authors, which is narrated on the basis of alphabetic manner. So I have included totally 4 studies. I have included in different point of time they have conducted. Okay, so this is a one study. This is 4 study totally. I have included for this meta analysis. So this is arranged on the basis of alphabetical orders. Okay, as Bhumika said, it is an x-axis. This is an y-axis. This middle line, I hope you can able to follow my cursor on the laser point. This middle line is said to be null effect or the no effect line, right? This one, it may be a mean score, or the meta-analysis can be performed on the basis of mean score or relative risk or odds ratio. Here we can say, I will give you the other explanation also. Here we can say the mean score. It may be the positive in nature. Here it's in the left side, may be a negative in nature. Okay, it may be a favorable or it may be an unfavorable. Okay, these both side are there. I will come to the clear explanation in the forthcoming slides. Okay, so these lines, yes, this line indicating the confidence interval of the particular study. Huh? Okay, you have to see the length of the line as well. If the length of the line it is too high, you see the 4th study, length of the line it is so long, it indicates it has less quality comparatively the short confidence interval. Very clearly explained by Bhumika regarding this confident interval, which is nothing but the lower level of values and higher level of values. Between the most of the 95% of the samples may be falling into these categories, this level and between this level. This is all about confidence interval. You see the last one, it's a too long confident interval. It has less, quality of work. If you consider, if you get the less length, it means it has more precise in the result. This also it matters. And I hope there is a representation of square that indicate the effect size of the individual article. Okay, this is a 2007. They have performed more the effect of the particular article, which is measured in the form of square. If the square size increases, the quality of research work also which increases. It means it also denotes the sample size of the particular study. If there is if they maintain the normal estimation of the sample size, the square size may be big comparatively. The other things, if you are not followed the adequate sample size, the size of the square may goes it may be little smaller than the good one, right? See, you comparatively, this first one is bigger sample size comparatively the second one. So according, by seeing the chart itself, we can able to understand the quality of research work. Yes, whether it is on favorable side or unfavorable side, and this length is confidence interval, and the quality of study as well as sample size, which is denotes in the square. So, and the size also be. This the diamond shape will be created at the bottom of this the chart or the plot, which indicate the overall pooled effect of the studies. It means where the the diamond falls, whether it is a favorable side or unfavorable side. That is the matters here. Okay. For an example, I will show you with the example in the next slide. So it's fall on unfavorable side. For an example, it may be the diamond will be falling on the unfavorable side. It means your treatment which is not effective. I am taking the same example of oxytocin, which is reducing the negative. For an example, this if it is in the wrong way, I can able to interpret that these all the studies stating that your oxytocin, which is not effectively reducing your negative symptoms of schizophrenia. Okay, that is all about the diamond representation. It means pooled effect of the all the studies. It's so in case if the diamond which is fall on the null effect line, we can be interpret in such a way that there is no positive or no negative. Though you are taking the medicine, there is no such observation you have we have received. There is no positive as well as no negative. There is no significant effectiveness. There is no significant loss in that particular study. So in case if the diamond is falling on the right side, we can say that there is a significant effectiveness. It means oxytocin has some potential effect on reducing the negative symptoms of schizophrenia. So coming to the next slide, you can see here also I have used, you can follow my laser point. Here we have used four different studies on the same parameters. It means the study problem would be same, right? That is all I told you the parameters. They have compared for some kind of, problem. They have used two kind of surgery. One is conventional surgery, means old way how they have performed, and newer surgery. It may be the laser surgery would be the newer surgery. The old one they might have conducting some other surgery. They have seen the outcome of prognosis by performing the conventional surgery as well as new surgery. See the mean score and standard deviation taken from the group in both conventional as well as new surgery, and the weight of the study. Also, there are a lot of software which is available when you're putting all these mean differences and standard deviation in the software, that will be giving the weight of the particular study, right? Okay, we can take the weight of the study here 14. Okay, so you can see the mean differences 2.60. It's a mean differences between the conventional surgery and the new surgery. And in the bracket, you can see the confidence interval 0.97 to 4.23. So you look at that forest plot here. This right hand side, it's showing the favor to the new surgery. Left hand side, it's showing that favor to the conventional surgical method. Okay, so all the four studies are statistically, as sir morning we have discussed, uh, whether it is a statistically significant. You see that second study, it shows that the point which is coming in the favor of for new surgery, that is statistically significant, whereas clinical, see confident interval which is crossing the null effect. It means there are some, may not be effective also. That is what the confident interval trying to explain. It's a negative. It's supporting the unfavorable, sorry, conventional surgery as well. So you look at here, this is a middle line. It's a no effect line. Most of the studies would be fall in the favor of new surgery. So the confident interval also, which is here, the second one is crossing the null effect, and third one also crossing the null effect. But the diamond which is present in the side of favorable to the new surgery, so we can able to interpret in such a way, yes, the new surgeries are having better outcome comparatively than conventional surgery. This is the overall understanding by looking at this forest plot, right? Then as I told you in the previous slides, this forest plot can be conducted based on the two, the data with the help of mean differences also can be conducted. Also relative risk and odds ratio with the help of odds ratio and relative risk. That is the second B, which with the help of odds ratio, this is the odds ratio. With the help of odds ratio, we have made a forest plot over here. Here, the diamond which is falling on the null effect line, it means it is not in the favor of new surgery, not in the favor of conventional surgery as well. So there is no such significant outcome would found through this meta-analysis. You can perform conventional as well as new surgery. There is no much differences. That is what this the forest plot trying to explain. Going to the next slide. Here, I would like to take you to the previous slide. I have broadly classified this meta-analysis into two types. One is a primary, another one is a secondary, right? Okay. One is primary analysis, another one is a secondary analysis. So far, we have discussed about the primary analysis. Our focus was only one, whether there is conventional surgery is better or the new surgery is better. That is the only objectives we had that we have done it. Okay, now here we are coming to the secondary analysis. It's a secondary analysis, little deeper we are going inside. So it's a subgroup analysis, means as the primary analysis, we are stopping with that particular understanding whether it is favor or not favorable to that particular treatment. So in secondary analysis, we are going to the subgroup analysis or even going in depth here, whether I want to say whether this surgery, the new surgery, it's favorable as it's a good for the people or the better prognosis. Then along with that, whether the males are getting more prognosis or females are, I am going in detail. That is all about subgroup. Male are getting good prognosis or females are good prognosis. Or age group, you are deciding them whether more than 60 age group people are having the better prognosis with the surgery, or then less than 50 years of age people are getting better prognosis. If you talk about in deeper understanding, that is all about subgroup analysis. I am having an example slide. I will show you little later after the explaining the sensitivity analysis. I hope you understood about the subgroup analysis. This primary analysis having only one objective and we are reaching. Once we have achieved the objectives, we are going for the secondary analysis. That means subgroup analysis, or even we are going in depth to understand certain particular characteristics of an individual, how it is affecting the result. So okay. Going to the sensitivity, this is an example of subgroup analysis. Imagine a meta-analysis of the new diabetic drug. Overall, the drug seems moderately effective. Okay, but when you are doing yes, first plot trying to explain drugs seems to be moderately effective in reduction of glucose level, but whereas the subgroup analysis that men shows strong benefit, or women shows no benefit. If you further understanding all those things, people from the low income areas are more improvement than those from the higher income areas. So something we are doing in depth, that is all about subgroup analysis. Coming to the sensitivity analysis, it means to finding out the trustworthy and reliability of the article which is being chosen by the researcher for the meta-analysis. Okay, for an example, I have collected nearly 5 to 6 independent study for my meta-analysis. Imagine I studied about new cancer. Okay, they have given an example of new cancer treatment. For that, I have selected. Okay, amla extract would be treating or reducing the cancer cells as well. Nowadays, there are a lot of research which is going on. If the person is going for the fasting for the longer time, even it is reducing the, it's destroying the cancer cells as well. That recently there is an article that published in the UK stating that long term, the frequent fasting can reduce the cancer cells as well. That's so if I want to do some systematic review or meta-analysis on that particular point, I'm collecting nearly 7 to 8 article. Uh, I with all the criteria supposed to be followed while selecting all those things. The original result showing the treatment reducing the cancer by 20%, for an example, after the particular treatment reduces about 20%. Okay, now I'm excluding the low quality studies, right? I told you 7 studies I have included. I found somewhere the standard of particular study it's not good, so I'm removing 2 studies out of 7. So still, if I'm calculating the meta-analysis, if I'm getting the result of 20%, then your data is so reliable and your analysis is so reliable. So I'm reading it. Now we are excluding the low quality studies and reanalyzing the data. If the new result still shows 20% reduction in the cancer burden, it means the result is stronger and reliable. But whereas if the result dropped only 5%, it's suggesting that low quality studies had a big impact on your outcome. It means your study, which is a low quality study, which is spoiling your result. So it is that is what we have seen in the previous slide. It's so crucial and so important. The result of meta suitable attention is not been given. Yes, if you are not, if you're including something low quality studies in the meta-analysis, it's a highly misleading. It is creating a lot of miserable effect on the patient's life. So we have to be very cautious when we are selecting the article, when we are critically appraising the article. So we are selecting it, right? That is all about sensitivity analysis. This is coming under the secondary analysis. Okay, I hope you understood. I will explain this subgroup analysis with the help of one chart. See, this is all about subgroup analysis. Uh, what they you see my laser points, which age group of people are more favorable to the conventional and neurosurgery. If the person age group, if it is more than 65 years old, you see all the result of the studies which is falling on the favorable to the new surgery. It means, and you see, look at the section B here, 1.1.2, it lesser than 65 years old people having, so only you see the diamond where it is placed. Yes, if it is more than 65, the diamond indicating that you can go for the newer surgery that will be giving the good outcome for you. Then, if it is less than 65 years old, So the diamond will be touching the null effect line. It means it is not supporting the favorable to, it's not supporting the new surgery as well as the old surgery. I hope you understood. So there is, here the p-value says it is not significantly effective in case of the second point. Here you see the p-value 0.0001. It's a highly significant, means there is a significant effectiveness in the new surgery, whereas here the p-value is not more than 0.01 or 0.05. It's a value is 0.10. It's a higher than the 95% of confidence interval. Therefore, it is not have significant effect on that particular area. This is all about subgroup analysis we can able to understand through the forest plot. One more thing you need to understand in the forest plot is heterogeneity and homogeneity. This also, which is playing an important role. You see, the I square, here it is visible. The I square, here there is a value. This is a 0%. It means here there is no heterogeneity at all. Heterogeneity, matlab, it means there is no differentiation in the collected research. For example, 5 articles I have collected. The 5 articles also, everything are similar in nature, similar in terms of research design, in terms of number, in terms of, the randomizations, that everything are similar, not it's deviated from one another. It is all about I square. Based on this, we can able to understand there is no heterogeneity. Also, by seeing this plot itself, also we can understand where this square placed. Okay, everything here there's no heterogeneity. You can able to say here. You look at the second forest plot. Few things were pointed on the null effect line. Few are in the right side. So, but you see the heterogeneity here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nine study they have chosen, but there is a lot of heterogeneity which is played over here. And the homogeneity means the first one, it has no heterogeneity. We can appreciate, and we should not have more heterogeneity. Which comes means we need to probe more what is wrong in the particular studies. So I will tell you with the description as we have discussed in the forest plot diagram. The box what we have seen in each row representing the effect size, mainly the main result of the individual study. Also, which is considered the box size, it's a differs based on the sample size of the individual studies. The size of the box usually reflects the weight of the study analyzed. The larger box, it denotes the more weight. The lesser in size, it has less weightage. Next one, we'll move on to the horizontal position of the lines of the boxes, shows estimated effect size. It means the mean differences, odds ratio, and relative risks. Coming to the next one, confident interval, the horizontal lines which is passing through the square. That is all about the confidence interval. The horizontal lines through the each box representing the confidence interval. The effect size usually at 95% level. What does it interpret? If the confidence interval does not cross the no effect line, means example 1 is the odds ratio. If you take mean score, 0 would be in the middle line. The result is statistically significant. For an example, if what I'm trying to say, if the line which is not crossing the no effect line, it means statistically it is significant. If the confident interval it is crosses the no effect line, the result is not statistically significant for the study. Next one. The vertical line, as we have seen, that is all about no effect line. Often odds ratio it start with 1. In case of mean scores, it start represented with 0. The interpretations of these, if the yes, that is what we have discussed. If the confidence interval crosses the no effect line, the study result is not statistically significant. If the box or the confident interval is to the left or right side line depends on the whether the negative or positive effect is expected. It indicating the significance of result. Second, somebody is waiting. Okay. Coming to the last point of diamond shape, it indicating overall summary estimation of study. As I have given example of 7 studies, 4 studies I have collected, gathered, and pooled all those data that giving some results. That is all about diamond shape. At the bottom of the plot, you might have witnessed, you might have often see a diamond representing overall pooled effect size of the meta-analysis. If the diamond crosses, yes, crosses the no effect lines, the pooled result is not statistically different. It means crosses means it's fall on the particular middle line. It means there is no, it's a not statistically significant. If the diamond does not cross the line, it means the overall result is statistically significant. If you see the interpretations, there are two types of diamond. One is a narrow diamond and is a wide diamond. What I have shown you in the previous slides are the wide diamonds, which indicate more uncertainty about the pooled effect comparatively the narrow diamond. If you get the narrow diamond, the pooled effect it's so precise, means more reliable. We can rely on the particular treatment so effective comparatively the wide diamonds. That is all about diamond. I hope you understood. We'll move on to the next slide. The last, I think, last one. Yes. I spoke about heterogeneity. It means there is no similarity in the studies. If you found that is a heterogeneity. See, sometimes you will see I square in the bottom of the forest plot that indicating, which indicating the degree of heterogeneity. That is a variability in the result across the studies, right? The result of the study varies. I square value range from 0. There is no heterogeneity. That's what we have seen in the slide. And there was no heterogeneity in case of 0%. In case of 100%, highly it is heterogeneity in the result of the independent studies. If you talk about interpretations of if the I square value fall between 0 to 25, suggesting that studies are relatively similar in their result. Most of the studies stating that yes, this treatment is more effective on the particular problem, right? That I square, if it is falls between 26 to 50, it indicating that there is a moderate level of, still we are accepting it. There is a moderate level of heterogeneity which is available, but still we can able to accept that, system of treatment. The last one, if I squares above 50, it's suggesting that there is a significant variability across the study. There are a lot of differentiations in the result of the study. Okay, and it may be worth investing. Why different studies having different result? What is it? It may be the cultural differences. It may be the changes in the you know samples. It may be some problem with uh, uh, bias in the data collection. there would be a lot of issue might have happened that the results are not similar. We need to prove more to understand why the differentiations the results. Okay, this also can be done as a secondary analysis. I hope this meta-analysis is clear for you. This all about this helping the nursing people. We are new and stepping into evidence-based educational system or evidence-based practices. Nowadays, we are doing evidence-based practices, which is nothing but whatever the activity which we are performing in the clinical area, there should be some evidences. Evidences, it's nothing but the research proof. That is all about the evidences. As I discussed or mentioned many times, with a single study, we cannot able to make the evidence or we cannot able to make conclusions. So we need to get more number of studies to have a solid evidences. That is what the meta-analysis and systematic tools, which is helping us to practice evidence-based practice effectively. Ultimately, it's increasing the quality of nursing care. That quality of care enhancing the nursing professions. I hope these kind of research designs like systematic review and meta-analysis, which you will be inculcating all these designs in your research and try to come out with a new understanding you implement in your clinical setting to promote the quality services from the nursing, and also you will be the part of uh, no, you have to play an important role in the growth of nursing fraternity. Thanks for patience listening. If you have any doubt, we can have a discussion for another 1 or 2 minutes. If you have any doubt, you can have a discussion. So there won't be any doubt. Probably there won't be any doubt. I think so. So I'm winding up. Thanks for listening to me. And once again, thanks to Principal Ma'am for giving this opportunity to deliver my lecture in the very huge platform that I have seen a number of people are participating from different part of India. So it's very happy, and I'm very delighted to share my knowledge to the people from the different part of India. Thank you so much. So,
Thank you so much, sir, for delivering such an insightful session on meta-analysis and forest plot interpretation. Your expertise has greatly enhanced our understanding of these important research tools. We truly value the time and effort you have dedicated to making this session impactful. So, on behalf of the organizing committee, I am honored to deliver the vote of thanks at the conclusion of this successful national level e-workshop on addressing sample size estimation in complex study designs and strategies for critically appraised RCTs. First and foremost, I would like to express our heartfelt gratitude to our esteemed Honorable Sir, Founder President SVDU, and Honorable President Sir SVDU, and whose valuable support and guidance have been instrumental in making this event a reality. Your unwavering encouragement and vision have significantly contributed to the workshop's success. A special thanks to our Honorable Chancellor Sir SVDU and Honorable Vice Chancellor Sir SVDU and Honorable Pro Vice Chancellor Sir SVDU and Honorable Registrar Sir SVDU, who has always provided constant support, ensuring smooth coordination and logistics throughout the event. Your efforts have been essential in organizing such a comprehensive workshop. We are also deeply grateful to our organizing chairperson, Dr. Anita Prakasam ma'am, for her continued commitment to academic excellence. Your leadership and dedication to fostering an environment of knowledge and growth have been truly inspiring. Your meticulous planning and dedication ensured that every session ran smoothly and the workshop was enriching for all. I would like to extend our deepest thanks to the organizing secretary for managing all the intricate details of the workshop, ensuring seamless execution and offering continuous support to all the participants. A heartfelt thanks to the IT department for their invaluable support in ensuring the smooth and successful completion of our online research workshop. Your dedication in setting up the technical infrastructure and ensuring seamless connectivity has made a significant impact. Finally, I would once again thank to each and every participation for their constant support in the sessions, and we would like to look forward to more such enriching experiences in the future. Thank you all for actively participating in our workshop. I would like to share that you will receive, all the participants will receive the feedback form link in their mail IDs. So once you fill the feedback forms, you'll get your certificate regarding this workshop. Thank you all. You may now leave the meeting. Thank you.